Let's do it, alphabetically. Kaya, no, let's do it alphabetically. So we start with, sino ba yung Miss Ginto ang una pala. Oh. So Miss Ginto, Mr. Liwag, Mr. Mateo, Mr. Obile, Miss Olesco, Roman, Miss Santos, and Miss Temporado. Ganon, no? So, parang yung item 1, si Mr. Ginto. Item 2, Mr. Liwag. Item 3, Mr. Mateo. Ganon, and so forth. No? Okay, so let's start. Kay Miss Ginto, can you please share your PDF file?
Okay po, sir.
Oh. Can you make it larger, please?
Wait lang.
Konti pa, para makita. Okay. So, okay na yan. So, your topic is applied geochemistry. No. So, can you please explain this briefly? No. What is the definition of applied geochemistry?
Okay po, sir. So, geochemistry is broadly concerned with the application of chemistry to virtually all aspects of geology. So, geochemical exploration is any method of mineral or petroleum exploration that utilizes systematic measurements of one or more chemical properties of a natural occurring material. So, the materials analyzed mostly commonly are rock, soil, stream, and lake sediments, natural waters, vegetation, and soil air. Ores of metals such as copper, nickel, and gold are the most common targets of geochemical exploration, but non-metallic commodities such as diamonds, talc, and fluorite, and deposits of oil and gas are also sought by geochemical exploration. So, in the applied geochemistry branch, it supplies expertise in geochemistry and biogeochemistry to characterize the natural water chemistry, processes controlling groundwater flow path, water-rock interactions, and fluid transport of metals and other contaminants in groundwater and surface water. Another focus is on constraining processes that form critical resource deposits and the development of geologic reference materials essential for validating analysis of earth materials. So basically po, pagka-intindi ko, applied geochemistry focuses on studies of the presence of elements and the geochemical processes that take place in rock, soil, and water of the on the earth's surface. So sa example ko po, it is the geochemical anomaly maps of gold, silver, copper in the study area. Tapos yung map po is galing sa map obtained from ASVADI 2004. So makikita po dito sa map na yung mga anomaly po na doon sa area na yon, which is so yung sa mga tawag nito, red, mas darker na red, mas high po yung content ng
Okay. So in short, it is when you say applied geochemistry is applying the principles of geochemistry in terms of the presence and also the distribution and the transport of these metals and elements that will be used for different applications. So mainly, there are at least two main not really branches, yung scope. One is for mineral exploration or petroleum, and the other one is for environmental purposes. So yung environmental means all other aspects of geology related to the environment. And geochemistry is very helpful, especially in terms of determining the presence of pollutants and also the presence of other metals and elements. Okay, yun yung pinaka-dapat tandaan ninyo in application of geochemistry. It is for exploration and for solving environmental problems and understanding the movement or transport of the different elements, whether they can become useful, beneficial, or they are hazardous or uh, dangerous to public health. Yun yung iniiwasan, no? And geochemistry has a direct tool because you can actually analyze the presence of these toxic metals and hazardous elements or chemicals. Okay, yes, that's good. Next, can you please unshare and then sino yung next after kay Miss Ginto? Mr. Liwag. Oh, naka-online ka na ba, Mr. Liwag? Wala ka ba, Mr. Liwag? Do you have a, audio? Pwede ka bang di sumasagot
Sir, naglolo ko pa rin daw po. Nagchat-chat po siya sa akin. Magre-restart po siya ulit.
Gano'n. No? Sige, di-skip na lang natin si Mr. Liwag, So, yung second topic, ito na mag-press, ikaw na lang mag-upload, please. Palagpasan natin si Mr. Liwag na for the meantime. So, after Mr. Liwag, it is Mr. Mateo. Can you upload?
Yes po, sir.
Yung number 2 item na ang iyong i-briefly present. Number 2 item.
Sir, kita na po ba yung...
Okay, paki-enlarge.
Sir, okay na po ba yung ganyan?
Laki pa haba, please. Wala kaming makita sa diagram. Pwede mo pang increase. One more. Sige pa. Okay. And then you start with yung B. Sa B ka mag-start yung, ano ba yung next topic?
Sir,
Applied.
This is geochemistry po. So, geochemistry covers...
Teka. Number 2 item ba yan after applied?
Hindi. Ito po, sir, yung number 3 po.
Hindi. Pina-skip ko na si ikaw na lang mag-discuss ng
Ay, okay po.
Kasi wala eh. Yan ang ikaw, yan. Environmental geology, go on.
Wait lang po, sir. Isin ko lang po yung... Sure, yun po. So, ito po yung environmental geology. So, environmental geology is a discipline that aims to understand every aspect of ancient and modern Earth. So, it provides diverse skill required to work in many different employment settings. Earth is a source of habitats and resources. There is also a geologic aspect in every problem about environment. Environmental geology can be called an applied geology and a branch of environmental science. So, main areas of environmental geology study involves earth materials, land use planning, and environment hazards, hydrologic processes, erosion, and deposition, and mountain building. So, ito po yung napili ko po, sir, na diagram.
So, ano yan? What is that first diagram? Hindi clear, pero ano na lang interrelationships of what yan?
This is interrelationship po ng environmental geology and sustainability niya po sa alas kabuuan po, sir, related po sa sustainability ng science. Then relate po siya dun sa Envi-Geo. Parang hin-highlight po dito yung mga global environmental problems po na pwede pong ma-solve by applying environmental geology.
Okay. Ano yung next figure mo? May next figure ka pa.
Ay, malabo po. Sir, medyo malabo po eh. Pero yung nakuha ko lang po siya, sir. This is system structure po yung hindi niya po na aninag. Then, yung branches po niya po, yung alternative sources of energy, waste disposal, and pollution. Tapos yung sunod po is engineering geology development without destruction, earth processes and geological hazards po. terrain hydrogeology and water management. Last po yung earth resources conservation and management po.
About the environment is also view of geology, you know, kasi why? Because the geology is science, no? Yung geology is dealing with the earth and earth's processes and also the surface. Pero when it comes to atmospheric, meteorological, less ano natin involvement as geologists, but they are related when these other processes, no, atmospheric and meteorological are causing hazards, like what is happening if there are storms, thunderstorms, typhoons. So they generate a lot of rainfall and flooding and landslides. So yun yung example. But that's correct. This diagram is just a simple diagram, but it shows that all other processes can be explained, no, in terms of geological processes. That is why the geologist is one of the main expertise used in solving environmental problems. So you remember that. Then the word sustainability there, when you take up and by Geo, later on that will be more discussed. But in general, that is the concept of sustainable development. No? Ang ibig lang sabihin in order for us to survive, yung human race, we have to be able to plan properly, no? So that we are not only protecting ourselves, but we are also making sure there is economic development, protecting the environment, providing for social benefits for all the communities affected, and the future generations will also benefit from the resources that are being used today. Yun yung sustainable development concept. And yun din ang word, no? Sustainability is the key. That there is balance, no, in any development. And that can be done by the processes, no, that cause these hazards and other problems can be addressed by proper design planning, no, and assessment. So yun yung pinaka main purpose of sustainable development, and geology is one of the main branches of science. Environmental geology and the application, of course, of geochemistry in terms of pollution. Yun. Okay, you remember that, no, class? Yung dinagdag ko dito sa discussion. Okay, you can unload.
Sir, okay na po yung sa akin. Stable na po ako.
Sino? Si Mr.
Liwag pa. Liwag pa.
Ha?
Liwag pa.
Liwag. Nakapasok ka na.
Okay,
so,
na
ano mapupunta sa yung topic? Ikaw na mag-discuss.
Yung next na lang pa.
Okay, ano ba yung geochemistry?
Yes pa.
Okay, you can upload it. Umuulan ngayon dito sa... Can you hear me ba?
Yes po.
Yes po. Yes po, sir.
Yes po, sir. Yes po.
Kasi muulan sa background. Okay, can you please make it a bit larger, Mr. Riwa? Sige pa, one more. Yan. Okay na. Okay, you can please explain.
Biogeochemistry. Biogeochemistry is the study of the movement of material between different parts of the Earth system, including the lithosphere, hydrosphere, atmosphere, and biosphere. In order to describe the cycling of the material, figure 1 below shows the Earth is divided into several compartments, which is the lithosphere, the hydrosphere, atmosphere, and biosphere. It is also referred to as the reservoirs And biogeochemistry is then the study of distribution of chemical composition and movements between the reservoirs, such as the release of methane or hydrogen sulfide from the volcanoes, or the removal of nitrogen and carbon from the atmosphere by plant process. It reflects the fact that these elements are necessary for life and are elements for which life influences the distribution and chemical composition. This field of study is an important tool in exploration for minerals and metals, and it's something that is done increasingly because it is low impact and low cost technique that has minimal environmental disturbance, as it can be done by just taking leaves from a plants or trees and analyzing their chemistry. So a tree is basically like a natural drill rig that can be used to see what the geology is underground.
Okay, good, no? But in your definition, can you go back to the definition there, no? Actually, may kulang dyan. Alam mo ba yung kulang? When yung term bio means what? Yun ang kulang. There is one more missing sa keyword, no? When you say biochemistry, it talks about living organisms like people, animals, plants, di ba? Yung flora and fauna kasama yung human.
Di po ba, sir, kasama siya sa biosphere po, sir?
Hindi. When you say, biochemistry, sinasabi doon ay mainly, no? It is
okay
about...
po, sir. Or,
I'm not saying mali yung definition na to. Kaya lang sabi ko, kulang siya, no? It should be specifically talking about living organisms then. Na yun ang application, no? Although kasi when you say biosphere, of course, it is about living things. Pero the word biogeochemistry, very clear, no? It is the chemistry of living things. Yun ang mas doon. Yun ang first part of the definition. It is more pertaining to the metals and elements that provide life. Tama naman, no? But living things ang pinaka-key doon, no? So, yun lang ang comment ko dyan, no? Parang masyado maigsi. There is a better definition that it focuses on living things, no? Okay, and then ito rin. Meron ding word na kulang. It is about the different yung biogeochemical cycles, no? Yung how each element are distributed and transported in the earth's in the rocks, minerals up to the earth's surface, and then the other the hydrosphere and the atmosphere. Kasi yung rocks, minerals, lithosphere yun. And how they will also be consumed or used up by living things. Yun, no? It is about a general also definition of the different geochemical or biogeochemical cycles of different elements that are used, no, to sustain life. Yun. I just wanted to add those things, no? So parang kasi ito very simplistic itong nakuha mo. But when you actually want to focus on that, it talks about different cycles also. So parang meron kang nitrogen cycle, no? Phosphorus cycle, those are the materials for living things, especially yung carbon, no? Yung carbon cycle, kasi living things are composed of hydrocarbons, no? Yun, no? Yun ang composition of living things. So, kaya very specific dun, no? Yung mga carbon, oxygen, then nitrogen, and hydrogen. No? Kita mo, halos yun yung yun yung karamihan na pinag-aaralan when you talk about biogeochemistry. Okay, so you can unload, Mr. Liwan.
Thank you po, sir.
Pero I'm just discussing it na for everyone, hindi lang sa'yo. So you can remember that. So let me see. I will just check my own guide. No? Alright, sorry, hindi yan. Unload. Oh, ito. Wala, no? Saan na ba yun? Topic na yun. Ayan, no? So, biogeochemistry here, no? Yan, no? It is talking also about here, no? Look at this. Incorporation into living things. So, biogeochemistry is the study of the cycles. Do you see this, class? Can you see this discussion here, class?
Yes, sir.
Oh, yeah, no? So, ito yung naka-highlight, ano? There. So, in particular, biogeochemistry is the study of the cycles of chemical elements, no? Such as carbon and nitrogen, and of course, the oxygen, hydrogen, and their interactions with the incorporation into living things, no? Transported through Earth-scale biological systems. So, more focused, no, about living things in space and through time. So, these are the common biogeochemical cycles that are studied and how they interact, no, with the different spheres, no? Hydrosphere, atmosphere, the surface is called pedosphere, and then the hydrosphere, of course. The lithosphere or the rocks and the minerals. So it includes carbon cycle, nitrogen cycle, oxygen, phosphorus, sulfur, water, and the right cycle. No? Yeah, yan yung more specific, no? When I talk about the application of biogeochemical cycles. Okay, and then, correct ka din, it is used for exploration by sampling. No? Di ba you mentioned? How do you use it for exploration? So, biogeochemical prospecting, here, no? Yan, involves the sampling of living things. No? Or actually, not the whole living thing. Portions of it, like yung plants, yung stem, yung kanyang stem, yung bark, yung balat, no? Roots, no? And even the leaves. To detect high contents of metals, which are the metals are the nutrients coming from the soil. Di ba yun yung vitamins at nutrients para mag-grow yung isang plant? They absorb the nutrients, and these nutrients include the chemicals and the metals. Parang sa tao, di ba, we have to take vitamins, ano, yung mga A to Z. Pero may mga metals din doon. No? We need zinc, di ba? We need iron, no? And other essential, no? Metals as supplement. The same for plants, for the plants. So when they absorb this, from the soil, so in the plant stems, bark, no, and the roots, okay, doon mo sila makukuha yung mga different metals and elements. And then, yung plant must for necessarily the one taking the sample, because about exploration with the geologists doing sampling in the field. Okay, but there is a condition there. You only do that if it is difficult to take soil or rock samples. And where saan bang lugar yan? Yung mga thickly forested areas. Yung hindi ka na maka-access directly ng soil at saka ng rock, because the forest is covered by a lot of organic matter, yung tinatawag nating yung mga decayed roots, leaves and trees, yung mga dead vegetation, they are littered throughout the forest floor. Kaya ang hirap mag-sample. You will disturb the other ecosystem there. Kaya yung plants na lang, parts of the plants are the one sampled. Okay. I think many of you have discussed that. No? In fact, the others have even included the example of that can be also analyzed. Okay, so remember class, yung BioGK parts of living things, especially sa plants. Kasi naman, when we talk about when we talk about normal exploration, we actually take samples of rock, di ba? Rock, yung geological sample, rock, soil, no? River water, spring water, altered rocks, weathered rocks. Pero here, no, it's not a geological material. It is an organic material. Okay? Yun yung yun yung pinaka-difference, no? Sa basic geological sampling and biogeochemical sampling. But the aim is the same, no? They are going to detect whether the samples are rocks, minerals, soil, water. If the metals and elements there are elevated ang concentration, higher concentration than the normal found in these types of materials, then there is already an indication. That's a guide for geologists to possibly interpret there is a source there below the ground. Okay? Yan yung specific definition of biogeochemistry and how it is applied to exploration, or it is called biogeochemical prospecting. Okay, next, who will be the one to discuss is, I think, next is
Sir, ako po.
Mr. Mateo, are you there?
Sir, ako po susunod.
Yes
Tapos
po.
na po si Mateo.
Oh, sige, please, upload.
Sir, kita na po.
Sino ba to? Mr.
Obilia po, sir.
Sino ba yung kanina nag-present? Liwag, di ba?
Si Liwag po, sir.
Liwag. Tapos?
Tapos na po si Mateo, sir, kanina.
Oo nga pala. Kaya ikaw na. Sige.
Sir, Geobotany po yung
Geobotany. Pwede mong palakihin yung geobotany.
Sir, yan po.
Hindi, increase mo yung image mo palaki yan. Okay? O patingin muna nung sa taas, yan yung sinasabi kong biogeochemical cycle na example. Yung itaas mo image, yung biogeochemistry cycle. Patingin lang muna. O yan, no? So class, ito, yung typical biogeochemical cycle, it is for carbon dioxide. Yan yung sinasabi ko, different elements na part of living things, mainly carbon, nitrogen, oxygen. Ayan, so ito CO2. Okay, good. So let's go to geobotany.
So, geobotany is the field of geology in which we relate plants to the geological substrate. So, it is an analysis of vegetation to review the geological differences in the subsurface. So, it is the relation between geology and plants. Specifically, how plants can be used in geological studies. For examples, in the study of Alfred Wegener regarding continental drift theory, he used the fossil glossopetris to correlate the relation between countries. So, another example in which we can apply geobotany is the use of vegetation as an indicator in mineral exploration. So, geobotany is significant in the field of mineral exploration as it gives strategic importance in geologic mapping in vegetated terrain, which is then used for general geologic mapping and for the identification of potential mineral deposited in the area. So yung glossopetris po, sir, ito po yung fossil po yan, pero parang dinigitize lang po for reference. Ito po yung ginamit ni Alfred Wegener sa study niya po. So yun lang po, sir.
Okay, so parang ano rin, no? Kulang ng konti, you did not describe. In terms of yung for exploration, no, there is another term there. No? It is called geobotanical prospecting naman. No? When you say it's used for exploration. So yun na lang explain ko. Okay, you can unload please, and share. I will now share again the other. So this is the one about geobotanical prospecting. No? So what is it? It is the field of applied botany, no? That dedicates itself to specialized issues concerned with the landscape, environmental planning, agriculture and forestry, and other scientific studies for conservation. Ito yung definition na, yan yung general, ano? Muna, yung applied geobotany ang sinasabi ko, no? Not yet the prospecting. So you actually, yes, you correlate everything that is growing, no, in different parts or in different settings and terrain. Okay. And what for different purposes, no? Maybe for improvement of the growth of these different plants and different crops. Ayan. It is called the geobotany. Why? It is important. It's because where do they get their nutrients, the plants? They get their nutrients from the soil. And the soil is your product of weathering of your bedrock. So it is dependent on the original composition of the bedrock, what nutrients or metals and elements are going to be extracted by the roots for the growth of these different crops and plants. Kaya it is mainly used for forestry and agriculture because they know what species will grow faster or better in a different soil, in different soil types. Pero yung soil, you can correlate it with the different bedrock. Yun yung, yun yung geobotany. You correlate the parent bedrock with the type of soil and then the type of plants that can grow there or can flourish. So, yun yun, no? Yun yung basic, no? But when I say that also, there are now more specific types of plants that can grow in different types of soil. And also, that means in different types of geologic terrain. No? When I say terrain, it can be your intrusive rocks, widespread, or your ultramafic rocks, or volcanic rocks, no? And different types of sedimentary rocks like limestone. So, meron mga specific types lang of plants. So, when I say specific, we are talking about species na. No? Yung talagang yung plant that is more favorable to grow. Yun yung mga tinatawag natin species, specific type of plant na yan. Okay, so because of that, we are able now to use it also what types of plants grow in areas of soil where there are high values of metals and elements. Kasi there are specific plants that can only grow or they can tolerate high levels of metals. And even the metals there, the type of the metal, no? Whether it is gold, copper, no? Uranium, they can sustain a specific plant species. No? Kaya yung mag-grow dun sa mga high concentrations of metals, specific type of plants din. No? Yun yung tinatawag nating indicator plants for a specific type of metal or element that comes from a mineral deposit that is already weathering. Kasi kailangan mag-weather yung deposit para ma-decompose yung rock ma-release yung metals and elements and they are found in the soil profile already. At yun yung nutrients ng mga roots na kinukuha ng roots, and then it will make the plant grow faster or it can make the plant survive. No, even there are high values of metals and elements. So, botanical prospecting refers to the identification of specific plant species or indicator plants like metallophytes. Ayun yung metallophytes is a general term for plants that grow with high metals content in the soil. Kasi they absorb it, that's their nutrients. And then also the analysis of the vegetation, the type of vegetation or what we call not only specific plants, but there is what we call a community. Hindi lang isang plant, but maybe there are several other types of plants that also grow in a soil over with containing high metal values. And when there is those high metal values, the geologist can correlate it that there is a possible source of mineralization. Merong nagwe-weather na mineral deposit. That's why these metals and elements were released during weathering, and they are found now in the soil profile where the plants are growing. Okay, do you follow that logic, class? Puro correlative, no? But it is found to be effective use. So ano naman yung mangyayari? So here, this is an example, itong right-hand side photo. It is an indicator plant for uranium metals, no? So yan, merong specific plant species. I was not able to get that, but I think in your other classmates' submission, meron na rin silang minention different types of species, di ba? Nandun, I was able to read naman that those are the examples used for prospecting. So, ang ibig sabihin nun, in the field, the geologist not only has a member of the team that is a biologist, yung yung what we call the one identifying also the different vegetation, but you can also have a specific expert botanist who can identify plants that grow in areas of high metal content. Yung nakaka-identify ng metallophytes. Mga expert din yan, Hindi lang yan basta tingin-tingin, and they actually can they're the ones to determining by inspection or also sampling these metallophytes. So, in a way, the geologist does not always need to be sampling the soil or the rock, but they also can rely on the input or the survey of a botanist, yung expert botanist who can identify metallophytes. Okay? So, hindi na nakapag-sample ng geologist, pero the geobotanist already says these plants contain a lot of copper, gold, or uranium, and they are already indicative of the presence of a possible weathering mineral deposit on the subsurface. So, ganon ang application of geobotany. So, where do you apply this? Also, in the same areas na highly forested. Kasi you don't need to go to this forest for a long time to dig. Just by looking at the biological, the clustering or presence of these metallophytes, there is already you can come up with a map, and then you plot this location of these plants, and then you will say, this is now a target for us. So remember in the different phases for exploration, di ba? I did not discuss too much about yung biogeochemical prospecting, but will also include geobotanical kasi it's not used here in the Philippines. Kasi exposed naman yung soil and rock. Okay. However, how do we use that also in the Philippines? Ang use naman niya is for what? For rehabilitation of mine areas. Diba yung sa mining area, there is already also the spread or decontamination of the soil. Diba? Kasi this is a natural process. No? The mineral deposit that is has already been mined there can also still even cause problems no, after mining. Kasi the metals and elements are still found in the soil. Ang kinukuha naman is the ore. Yung ore sa on the subsurface. Now, yung sa surface, yung mga soil are just removed and they are contained or disposed no, in other areas. Hindi siya tinatapon. No? They are just there no, for rehabilitation. Kaya lang, when you want to plant again, after mining, you rehabilitate the land. But the soil contains also the metals and elements. So how do you expect to plant other crops if these crops are not naturally favorable to grow no, in soil that contains high metal values? Kaya it is used for rehabilitation in terms of so here comes the environmentalist and the the geobotanist. They will recommend how to remove how to extract the remaining metals and elements in the soil by planting species of plants that are able to grow. No? And then that means it's a natural way of extracting the nutrients, and they are part of the plants already. They become incorporated in the plants while growing. So yung soil, gradually nare-reduce yung metal content. No? That is called what? Yung remediation, yung rehabilitation or remediation, bioremediation, using the plants, no, living things to extract the metals, no, in soil, no, in a mine area during rehabilitation. It's now used for environmental purposes, yung pagplant ng specific types of plants that are able to extract yung metals and elements. So, dalawa yung purpose. No? One is to be an indicator of mineralization, and then after it has been mined, that area, the plants are then the ones again used to remove yung remaining metals and elements in the soil after a mining activity. Okay, so did you follow that class? Yung dalawang biogeochemical and the geobotanical prospecting methods? Are there questions there, class?
Answer.
Okay, so that's clear to you, no? That is how living things are used, no? In prospecting, and in this other case, yung sa geobotany, it is also used for rehabilitation of mined out areas, no? By using metallophytes to extract the metals and elements, no, in the soil. Okay, so that the soil can be again used for more productive agriculture. But the problem there, it will take time. Hindi naman yan after planting, it may be after 5 months, 6 months. Hindi naman lahat matatanggal. No? It will take several years to really remove. So meaning to say, yung plants na nag-grow, you have to replace them again, and then that species of plant will have to grow again, and then remove again the other metals and elements. Okay? Ayan. So now let's talk about the next topic. Who is the one after Mr. Obile?
Ako po, sir. Miss Alesco po.
Oh, Miss Palesco, Miss Roman, Miss Santos. Oh, apat pa. Okay, can you please upload your topic.
Ayan po,
Oh,
sir.
medical geology. Can you make it a bit larger?
Ayan po,
Okay.
sir.
Please briefly explain.
So, medical geology is an earth science specialty which concerns on how geologic materials and earth processes affect the human health. Not just human health, but also other living organisms. So, geologic materials such as rocks, soils, dusts, and volcanic emissions can contain naturally elevated levels of elements and minerals and other compounds or microbes that can harm or benefit the human health. They can also contain human-related chemical, mineral, or pathogen contaminants. The medical geologists work with earth, biological, physical, and health scientists to help improve the public health. So another term related to medical geology is toxicology, which plays a key role in the studies of medical geology. Toxicology examines the harmful impacts of chemical substances, physical processes, and pathogens on human and animal health and on ecosystems, and provides a link between the occurrence of a toxic substance and its effects on the organism. Toxicity begins with exposure to the chemical substance, physical process, or biological agent, and this may result in a range of responses from mild to severe, including death. It also seeks to understand the mechanisms through which toxicity is manifested, including exposure pathways, transport within the organism or the ecosystem, metabolic transformations, modes of toxicity from the cellular level to ecosystems, and modes of removal of toxins. The significance of medical geology to earth science and to the community is that scientists have observed that some minerals has harmed human health and others are beneficial. They also related some of the diseases which were caused by environmental factors. Another is by as many more Earth health connections and their complexity became apparent, so did the need for the Earth scientists to connect with the medical and public health researchers, where Earth scientists working with other health researchers have made key contributions to identify geographic patterns of disease, find sources of disease-causing agents in the environment, and determine how people are exposed. So this diagram shows the geologic factors and the processes which can affect the living organisms. For example, in the atmosphere, the volcanic dust and gases and other atmospheric emissions will go into the atmosphere, which will turn into dust particles and gases, and this may be inhalated by the humans. If it may go to land in the form of soils, it may undergo weathering, biological cycling, or it may be dissolved in water into solution, which may be intake by plants and which may further be intake by animals and humans. So basically, it shows the relationship between how geologic factors and processes can affect the health of the living organisms. So that would be all, sir. Sir, okay na. Okay na po, sir.
Ay, sorry. Hindi niyo pala ako narinig, class. Hello? Naririnig niya na ba ako, class?
Opo, sir. Ngayon po.
Sorry. Ay, teka, ulitin ko lang, no? So, yung very good yung presentation, as I said, no, kanina, ako lang pala nagsasalita na you captured all the factors, no? And then also, I wanted to explain na yung medical geologist is not the one going to cure all the patient, no, with public health problem. Yung meron siyang toxic metals in his body. Yun yung doctor, toxicologist. Pero the geologist connects, no? The toxicologist with the source of these chemicals and elements that cause the problem. Kasi you cannot solve the problem if you do not know how it reaches the body. Diba? And it reaches the body through the geological environment, yung transport through the water, especially, and then pwede inhalation, no? Pwede yun. Like, for example, you have mercury and arsenic present in the hot springs, di ba? Epithermal deposit, hot springs. Merong arsenic, no? Mercury together with the sulfur. They are contaminants also if they reach the living things. They become toxic to living things. So, it is the geologist's response, the medical geologist is the one finding the source so that we are able to stop the transport of these toxic metals into the body that causes the health problem. Okay? At yun ang main role ng medical geologist. And that medical geologist, in fact, understands more, no? How these metals and elements are being distributed or transported. So mga species of this mercury and arsenic, maybe they are in compound form. No, kasi merong compounds ng arsenic and mercury, mas siya toxic. Like for mercury, it is methyl mercury or organic mercury. Pagka yan ay nakarating sa katawan ng tao or na ingest sa food or sa water, they will have this mercury intoxication or yung Minamata disease. Sa Japan kasi na-discover yun noong 70s. So, yung arsenic naman, yung metal na arsenic is not generally intoxicating, no? Pero when it is in a compound form like the arsine, arsenic plus 3 or arsenic plus 5 pala, it is more toxic to the body. So it is the medical geologist or actually also a geochemist can understand that, no, how these are the different compounds are found in the earth's surface, and they also understand how it is transported and it reaches eventually the body through food or water or by inhalation. Yung straight inhalation, madali yung ma-check, di ba? Kasi yun sa workplace, no, nakukuha yan. But if it is for drinking and food, it will take time before you can actually correlate. Everything it's coming from a natural. It can be a natural source, no? Like a hot spring, as I was saying. Yung pala yung source, nakakarating sa groundwater and the water table na pinapump ng community for their water supply. So it becomes a problem. Good problem. Okay, yun yung talagang role, no? But there has been meron bang medical geologist na doctor of medicine? Possible ba yun? Yes. In fact, we have one in the Philippines, si Dr. Socrates. He's the provincial doctor of Palawan, no? Provincial officer. And his forte is treating orthopedic patients na to grow their bones naturally by giving them food, nutrients, and supplements that help the bone grow faster but naturally. Hindi siya gumagamit ng mga metals and bolts. No? Siguro yung task, but that is normal, no? Ika-task ko para maging steady. Pero yung putting up different metal structures there so that the bone can be aligned or be healed. Hindi siya gumagamit. No? Kaya siya, natural, no? Healing. And it is applicable mainly also for the poor people who cannot afford to, no, yung maglagay ng mga high-tech gadgets in their homes. So yun, meron, it's possible that a medical doctor is also a geologist, or a geologist becomes a what? Medical doctor as well. Pero ang forte nila ay medical geology. Okay, so yun, no, you have to understand, hindi tayo necessarily the one at healing, no, yung toxins, no, yung sinasabi, toxicologist yun, yung binabanggit ni Ms. Olesco. But we are closely related because we know the species or compound that is the one causing the pollution or the intoxication, and then we also know the source. So once we are able to stop the spread from the source, we have solved the environmental problem. Pero the doctor does not actually know where it comes from. Ang kinitreat niya lang ay yung pumapasok sa body. Okay, so it's the same for veterinarians and for the animals. Meron din poisoning of animals, and then also for yung mga botanists, they know, no? Contaminated plants. Ayan, like in J-botany, no? They know na matataas ang level. Kaya mayroong plants na if they are not the species that are metallophytes that can naturally grow, they cannot survive in those types of conditions. Okay? Okay, so ayan, do you follow that class? Zoology ko. So in terms of how it is transported into these are the here at the bottom you see actinides, or they are the pollutants, no, metals that can cause pollution. They can come from natural and man-made sources, no, mining, agriculture, maraming ginagamit na pesticides, fertilizers, and phosphates, marami ang chemicals, and then metals from mining, yung nagkalat doon sa contaminants, no? They become contaminants of the water. Here, no, the water flows containing already the metals and elements, and then even coming from landfill sites or dump sites, no? And then they also are taken in by plants, and also yung water supply is taken in by humans as water supply. Yun yan, no? Yun yung importante, no? When you talk about medical geology, is connecting the source of these pollutants with the patients, no, that have been poisoned or intoxicated. Okay, now next is Miss, sino yung next natin class? Miss Roman. Okay, what's your topic, Miss Roman? Environmental geochemistry ba? Ano ba? Ano yung mo? Accuse. Okay, accuse. Actually, accuse is more also of environmental. O sige, please share, accuse. Na-check pa, hindi pa po mga yan. Pakilakihan mo lang, please. Lakihin mo pa. Ayan, sige. Okay, so ano yun, no, specific example mo. Pero if you go back, no, actually, yung accused J chemistry is a tool, no, of the ng isang environmental geologist or even the medical geologist, di ba? As I said, he will study ano yung sources ng metals, no, and how they are transported. So this is the example, no? Mostly the interaction of the rocks, minerals, yung mga toxic metals and elements and chemicals are released through the water. No, ito yung tool. No? It's accused J-chemistry ang tawag. Pero ang pinaka today, no, it's also what we call environmental J-chemistry. Kasi when you say environmental, it is like medical geology, no? Na to help solve the environmental problem, we have to understand the whole, no, process, the source up to how it is transported and how it becomes how it reaches, no, living things. This is the tool of a environmental or medical geologist. It's called accused J-chemistry. So parang na-explain na rin to, no? Yung sa previous discussion, ito rin ang example. Specific, but you are just talking here, pwede rin man-made yung accused J-chemistry, no? Because it is processing plants, they are the ones, no, contributing polluted water. Kaya yan ay naging accused J-chemistry. Also, pero it is meant to be analyzed or studied, ano yung impact niya or effect to human health. Kaya today, accused J-chemistry is also more used for solving environmental problems, just like it's a tool of medical geology and environmental geology in general. Okay, sige. Okay na. Who is next? Please unshare. Tignan ko lang yung aking
Sir, ako po. Santos.
Sandali. It's the same, no? Here, mercury naman to pinapakita, no? How it reaches humans there, no? Yeah, no? There is what we call bioaccumulation of mercury. The fish, no? Ingest smaller organisms, but in the first place, yung mercury is already present there in the water, no? By two things, no? Industrial sources, pollutants, and then probably also the volcanic eruption and erosion and weathering of rocks. They all find the sediments also containing this mercury, and then there is the action of bacteria called methylation, and it converts the metal mercury, yung Hg, into organic mercury. At yun ang nagiging toxic species. Kaya yan, there are nutrients also for organisms, aquatic organisms, and then there is accumulation here along the food chain. Habang kinakain niya yung mga snails ng small fish, kinain yung small fish ng big fish, and then the big fish is the one caught by humans for food. Diba? For food. So, and then napunta lahat yung mercury sa tao kasi through accumulation along the food chain. Kaya ito, eventually, if he always eats the fish that contains methyl mercury, he will become intoxicated with mercury. That's the example. At yun ang hinahanap ng medical geologist by connecting the source and how they are transported, and it reaches the humans that can cause public health problem. Yung tool dyan ay accused J-chemistry. Okay? Okay. Yan yung aking gusto lang idagdag dun kay Ms. Roman. Okay, now who is next?
Miss Santos po.
Okay, Ms. Santos, can you please upload?
Yes,
Can you please make it larger?
yes po, sir. Ayan, sir.
Sige pa, one more. One more enlargement.
Yan po.
Ayan, okay na, yan. Good. Okay, paki-discuss briefly.
So next is hydrochemistry. So hydrochemistry is defined as a field in geology wherein it deals with the study of chemical composition of natural waters. So it tackles the compositions of water, acid, and other fluid that is located in geothermal reservoir that serves for chemical stimulation and hydraulics. So by this, scientists can locate groundwater and determine its geology. So hydrochemistry is applied to determine hydrochemical characteristics and quality of water in groundwater. So the data acquired in this study will be useful in evaluation of corrosion of construction mineral waters. So in addition, the application geohazards assessment to avoid disaster and risk caused by contamination and the like. So here is an example of a hydrochemistry application. So in figure 7, we can see a conceptual diagram of sources and the moisture and salt migration of ground ice in the permafrost regions of the central QTP.
Okay, so ano yung gustong isolve the problem dyan is ano? I cannot read it. What was it? Solve?
Actually, this is part of a study, sir, wherein ina-analyze po nila yung moisture and salt migration po sa underground. So what are yung mga makikita doon, yung mga characteristics ng mga ano po.
So parang
sa
contamination of the groundwater. Yun
Apo.
yung gusto niya.
Yung mga environmental factors po.
Okay.
Explain din po.
Okay, so I wanted it to make sure, no? Kasi yung term na hydrochemistry, no, is the same almost as ano, no? Aqueous J chemistry, no? Kasi ang difference lang is what? It is more specific for freshwater yan. Is yung hydrochemistry is used for natural waters pero coming from the land, no? In the land, freshwater yan. Diba? Yun lang, no, class? Ang naging difference lang ay pang freshwater yung aqueous J chemistry na application, no? But the original terminology is hydrochemistry if you are dealing with the study of natural waters or fresh water, no? Sa land yan. Pero we are also involved, you can involve also yung pag nag-mix na yung saline water, yun yung lacustrine, ano? Pwede rin, no? Umaabot up to the level of lacustrine yung may mixing kasi it's both fresh water and marine water, no? Yun yung ano, boundary niya. Okay, so the same, no? What are the species and how these metals and elements again are transported. But not necessarily only for living things, no? Reaching living things, but the other parts of the environment. But in your example, it's for the groundwater, it's the monitoring the possible transport of saline, yung salt that makes the water saline, and then hindi na magiging safe for drinking in the long run. Okay? Next. Yun lang ano lang, no? Yung difference ng ano is for fresh water. To differentiate from yung next topic. Ano ba yung next topic? Kanino ba yun?
Akin po, sir. Marine po.
Sino Mr. Corrado na ba to?
Apo.
Okay, please upload.
Kita na po ba, sir?
Hindi pa dumadating. Yan na. Okay, can you please briefly explain?
Marine geochemistry is concerned with compositions of coastal marine water and sediment. The application of marine geochemistry is applied for coastal and marine management to be able to protect the ecosystem of living things underneath and the quality of water. The chemical changes in the past and in the present of marine bodies can be investigated and develop a greater understanding through the study of marine geochemistry. Marine geochemistry is applied to be able to aid the reconstruction of ancient ocean redox. molybdenum is a key component in the process of reconstruction, including proxies, concentration, and isotopic composition. As you can see in the diagram, this illustrates the schematic presentation of molybdenum isotope mass balance model for the modern ocean. In marine geochemistry, it is used to be able to know the chemical substances in the ocean, to make solution for if there is a contamination and to be able to protect the organisms underneath.
Okay, yun lang
Yun
ba
po,
ang
sir.
example, no? So,
Apo.
okay, so I will just add some more things. So, do not unshare first. No? Can you please make it larger again? So, yung binanggit mo lang is, of course, correct, no? It's about concentration of nutrients and carbons, no? But it also involves the metals and elements, no? Kasi lahat ng nasa water table, nasa periodic table, they are found, no, in the oceans. Why? Because the oceans is the final repository of all that is weathered or transported from land, di ba? Kaya doon naiipon lahat ng na-erode, na-dissolve, they reach the sea. Kaya almost all of the metals and elements are found in the sea. And the key here is when you want, ang pinapag-aralan nito is you are trying to understand what happened before, no, yung ancient, no, ito yung example mo, no. Para kang you are using isotopic molybdenum, no, to be able to understand, no, paano nagkaroon ng why the present seawater is like this, no. Ano yan, para kang forensic science yan, yung looking back at what happened, no. That is academic research yun. Pero what I will mention now is if we apply marine geochemistry, no, for the future, ito yung application for climate change. Kaya na-understand na merong climate change that have happened also before, no? Because you will see the content of sediments in the oceans, di ba? Meron yung mga fossils, no? If you are able to drill, no, in the ocean floor, mga layers of sediments, nalalaman din nila na meron palang mga climate change before, and then yung present day is similar to possibly yung mga nangyaring climate change before by looking at the composition of the sediments. So ito ay hindi lang water, kasi sabi, marine geochemistry, but it is the interaction of the sediments and the water as well. So that is why today, no, inaaral na rin yung present day sediments, no, ano ba, may indication ba na some type of metal and element are being enriched, or meron bang nawawala? That is an indicator for climate change already. Plus, yun, so sediment, but the actual water content of the present seawater are the indicators also, no, of the worsen na ba yung effect ng climate change, no? That is what yung mainly are there greenhouse gases also being contributed by the sea already? Kasi yung climate change is carbon dioxide and methane and other greenhouse gas, nitrogen. Pero yung evaporation of the seawater has a large contribution kasi the earth is composed of 3/4 is seawater on the surface. So pag nag-evaporate yan, nagko-contribute din siya ng greenhouse gas. No? So yun ang mga inaaral today, yung looking forward, no? How we can help solve climate change. At ang isang tinitignan yan, how can the seawater be able to capture most of the carbon dioxide naman. No? Ito yung aking example. No? If you are able to, in the sea, no? If the seawater has a lot of, you have, di ba may carbonate yan, no? Sorry. Yung carbon from the atmosphere when it interacts with something, magkakaroon ka ng compound that can precipitate. So nawawala yung carbon dioxide doon sa contact with the seawater, di ba? Pagka nag-contact yan, nagkaroon ng interaction, yung carbon dioxide in the atmosphere, yun ang ating ina-avoid, no? Increase of greenhouse gas na carbon dioxide. It will now cause precipitation and then it will precipitate into the sea. no? Yun yung gustong aralin. Ano ang pwedeng mangyari? We introduce something that when they interact in the surface of the seawater, the carbon dioxide is removed from the atmosphere. So we lessen the carbon dioxide as a greenhouse gas. Yun ang tatawag na, the term there is finding carbon sink. Yung where the carbon will not be released as into the atmosphere. Carbon sink naman ang tawag, we precipitate it. So ano yun maiisip nyo? Di ba yung, what is a carbonate, no? That is usually found in that is a mineral. Di ba ano yun? Di ba may calcium carbonate, di ba? And then, but we can also add something, maybe iron. If we have a lot of iron, we can add. It will also form another carbonate, no? Fe naman, FeCO3. No? Yung something like that, no? It can form siderite. Yun ang pinag-aaralan. What can we use to introduce naturally also so that we remove carbon dioxide from the atmosphere, but they are all precipitated into the sea. Yun naman ang isang research. Okay, so class, now you have already understood, no? What are the different terms. But if you will see, almost all of them, no, use geochemistry, di ba? In solving environmental problems, no? They use mostly geochemistry. Ano lang yung hindi directly nag-use ng geochemistry, yung geobotany, di ba? Kasi you are not analyzing them, no? You are just looking at plant species. Pero yung biogeochemistry, you analyze the leaves, plants, and the roots and the stems. So, geochemistry pa rin is applied. Pero yung sa geobotany, hindi ka tumitingin ng geochemical composition but the plant species. But it is used for exploration. Kaya sinama na lang yan sa topic, no? For application. For mineral exploration. Okay, but all the rest, they are using geochemistry. Kaya geochemistry has a big role, no, in exploration and in solving environmental problems. It is a tool that is more direct. Kasi hindi ka na, unlike geophysics, no, you are just assuming that there is a body or a model that causes this geophysical anomaly. But in geochemistry, it also tells you directly anong elements and metals are the ones causing the problem already, or the sources of these metals and elements. Okay, yun yung difference also. Okay, are there any other questions, class? Doon sa discuss natin different topics in your assignment. So I will not discuss the indicator and pathfinder kasi part of the lecture naman na ngayon. So what I want to mention here is that when we reach the topic of indicator and pathfinder metals, no, they do not talk about, no, yung zoning of alteration, no? Hindi yun ang hinahanap natin, no, for indicator and pathfinder. Kasi merong mga nag-submit, they talk about the zoning of these metals and elements, no, in the altered rock or in the what's this, the zone of mineralization. Kasi very distinct yung separation ng indicator and pathfinder, which we will talk about, no, or we'll discuss, no, in the next lecture. Yun lang naman, kaya hindi ko na in-include yun kasi you will be better understand it. It's not about zoning of metals and not even alteration zoning. Iba yun, petrological yun, yung mineralogical zoning. It's not geochemistry. Okay, so class, let's have a break muna. Let's have a 10-minute break. So you come back at 10 to 2, magkape na tayo. Mag-stretch legs and kape. Okay, class? So, Miss Roman, you can stop the recording first. Miss Roman? And then we come back ng 10 to 2. Let's come back. You magano kayo, stretch and drink coffee. Sige. Start the recording. Oh, meron pa pala itong akin pala ay naka-expose pa. Wait meron pala akong, why is it I have this slide? Oh, what happened? Nawala yung aking screen. Oh. No, sorry. Naligaw yung aking screen. Sorry, class. Naliligaw. I want to check something first. Ayun. Okay, so this will be our next topic, Little J chemistry. And then the secondary environment. So parang primary environment ang Little J chemistry is about the rock. And then the secondary environment is where you have the weathering and erosion. Okay? Kaya tawag yung secondary. Primary is the rock. Okay, let's discuss these things first. Okay, do you see this screen, class?
Yes, sir.
Okay, this is the J chemical cycle in terms of the rock and minerals. Okay, so let me show you first the. Oh, sorry. How do I here? Ayan, reduce ko lang, masyadong malaki. Okay, this is the J chemical cycle. No? So you will see here that it involves both the there, now it's better. Can you see this now, class? Mas kita pa rin ba o maliit na masyado? But anyway, I will zoom to it na lang later. So as you will see, yung J chemical cycle in terms of rocks and minerals are separated by the surface. When I say surface, yung boundary between the rock that is still fresh. No? Fresh pa siya. And then when it becomes weathered and becomes soil because of decomposition and weathering, nagiging part na siya ng secondary environment. So this is that boundary, that yellow line here, no? That's the boundary between the rock, primary rock, and then the secondary environment. Okay, yun yung J chemical cycle that is being shown here. Okay, so Little geochemistry, which is our topic, we'll talk about the primary environment where the rocks and minerals were originally formed or deposited. Or if there are sedimentary deposits, yun yung naging deposition. No? They are classified as rock, sedimentary rocks. Then, if it is metamorphosed, the metamorphic rocks. No? And then, pagka-plutonic and volcanic, they came from the magmatism. Okay, yun yung sa primary environment. Para siya yung pinaka-original deposits or that have been crystallized, no? And they have not yet been weathered, except for the sedimentary deposits. Why? Kasi yung sedimentary deposits, they have been weathered and then they were deposited as sedimentary layers. But for the volcanic and plutonic rocks, no, they are the primary also. No? But mas original siya than the sedimentary rocks, diba? Okay? So, let's now focus on the primary environment. So, ito yun nasa below the surface of the earth, or that is below your soil profile and weathered rock. Kasi yung weathered rock na affected na siya ng weathering, kaya weathered rock. Okay? So I now focus on the primary environment, no? Yung where we find our original crystallized and formed plutonic rocks. Okay, so I'll now focus on that. So ito yun, no? Yung below this yellow boundary, do you see this class? Yan yung boundary niya. No? That is supposed to be the surface of the crust of the earth, no? Where there is uplift, erosion, and weathering that is happening. And where there is also sedimentation and diagenesis happening. Okay. So below here, now is the primary environment. No? As I said, that this is where you started to form the or crystallize the rocks. First by, okay, first of course is by magmatism. Ito yung sa bottom. No? There, deep-seated environment. So what is it? It is in the mantle, boundary between the crust and mantle. That is where you start forming your magmas. And magmas are what? Generated by subduction or by what do you call this currents, no, that are able to upwell, no? Especially without subduction, but they are able to rise because of spreading or separation of the upper crust. So nagkakaroon ng way na makarating yung ating magma. And the magma sometimes, they do not need subduction. They are formed by what we call mantle rise of material, mantle material that is rising. Mga mantle plumes. Okay, and then they eventually erupt into the surface. Yun yung mga hotspots. If you remember, no, may hotspots tayo. They do not need subduction. They are just rising along planes of weakness in the crust by mantle plumes. Okay, so this is now your original material, the mantle material. No? They rise from the depth and they are introduced at the crust mantle boundary, and then that's where they start to fractionate and differentiate. If you remember yung petrology and geochemistry, yan yung following the Bowen's reaction series, di ba? There is a sequence of magmatism depending on the type of magma. So you start to form ultramafic rocks, in general, mafic rocks, intermediate, and then the alkaline rocks or acidic rocks. Yan yung crystallization and cooling of the magma. And then, while it's cooling, it is depositing crystals. Okay? And yung magma is also differentiating through time. What is differentiation? It is the change in the chemical composition of the magma. As it cools, naiiwan na yung mga sa ultramafic rocks, naiiwan na dun yung magnesium and the iron. And then pag naging mafic, it now also becomes richer in iron and calcium naman. Wala na siyang magnesium kasi nakuha na yung magnesium ng ultramafic rock. So that nagdi-differentiate yung magma while cooling, and it is also depositing or crystallizing different types of minerals, no? Yung ultramafic minerals, mafic minerals, then intermediate minerals, especially the feldspars, And then the alkaline and siliceous materials or rocks. Yun yung naging primary deposits. Kaya primary environment, first originally formed from the magmas by crystallization and cooling of the magma. So, essentially, you form plutonic rocks. And then when they are erupted to the surface, they become volcanic rocks. So, yung plutonic and volcanic rocks actually come from magma or the lava that is rising. Okay? Ayan. So, they are found in the upper crust already. But until they are uplifted by tectonism and then already exposed to elements of weathering, no, and erosion, they are considered to be still primary. Hindi pa sila nagkakaroon ng reaction with the surface environment. But they are in the primary, no, environment. Yung mga original rocks. But of course, meron na siyang alteration, no? Meron ding hydrothermal fluids, but they are all still in the primary environment. Lalo pala sa below the surface. Okay? And then, of course, we also know there is metamorphism that cannot be avoided because there is a high heat flow or high pressure environments. These photonic rocks are converted to metamorphic rocks. Diba? Ayan, itong magkatabi. Okay? Now, how do we form sedimentary rocks? Naman, sedimentary rocks will have to undergo weathering. Before they are formed, you have to weather these original materials, the metamorphic and photonic rocks. And they are broken down to mechanical particles. Diba? And then they are also partly converted to other minerals that are stable in the secondary environment. Yun yung mga clays, hydrous oxides, yan yung mga products weathering. Pero yung mga residual primary minerals are those that are mechanically resistant, no? But they are already also they have been broken down from the primary rock. Mechanically transported, and then they are deposited as sedimentary rocks, maybe in the sea or in the land by rivers and streams. Karamihan, water lane. But volcanic eruption, when they erupt into the surface, when they fall down back into the surface environment or in the sea, they become part of the sedimentary process. They are also incorporated as volcanic sedimentary deposits, aside from the other precipitates and yung mga particles, no, of weathering or erosion. So they start to be compacted for a long period of time, millions of years, until they become consolidated, and they can be classified as sedimentary rocks. So pag naging sedimentary rocks sila, they are buried actually already. They are again buried or below the what we call the surface environment. Hindi na uli siya magiging subject to weathering and erosion kasi there is burial first. So itong mga sedimentary rocks here, no, they can through time, no, if they are by tectonism, they can again also become metamorphic rocks also. If they are subject to high pressure and temperature environments. So, sedimentary rocks, although they have come from the erosion and weathering of other earlier formed plutonic and volcanic rocks and precipitates from the surface, they become part of the environment, the primary environment. Again, parang na-recycle siya into sedimentary rocks yung mga particles from this plutonic and first form metamorphic rocks. Yan. So they become again part of your primary environment. So what is the general classification? If they are below the surface of the earth, not yet undergoing again erosion and weathering, they are part of the primary environment. So yung other materials that are deposited, like the sedimentary rocks, aside from being metamorphosed, no, as I mentioned, they can become part of what the when it interacts with another magmatic pulse, or there is a rising magma, they can interact and become melted, or what we call there is anatexis, and they become incorporated again into the magma, no? Which the magma will again crystallize later on new set of rocks and minerals. So that's the cycle, no? Yung metamorphic rocks have a longer, usually longer history. Okay, but they came from the original metamorphic rocks. Metamorphic and earlier form plutonic rocks. Okay, basta't nasa below ng surface, they are in the primary environment. At yung those that are in the primary environment, no, also are the host rocks. They can be together formed with mineral deposits, di ba? Whether it is magmatic segregation or hydrothermal fluid deposition of mineralization. Magkakasama sila in the primary environment. That's why our mineral deposits are also primary, no? When they are found together with the host rocks that are in the primary environment. What do we call now deposits that are on the surface? There are our, what we call our residual, yung mga na-erode lang na deposits. And then they form another type, no? Yung mga placer, no? Yung mga clay, gano'n, no? They are in the secondary environment already. Okay, so that is the primary environment we will talk about. So also, when we try to explore now for minerals in this primary environment, what do we sample? When we are talking about the primary environment, of course, we try to sample the bedrock, the host rocks, the country rocks, and if there are mineral deposits there, no, the altered rock and the mineralized or concentration, yung ore or the mineral deposit. Yan yung purpose of exploration. We sample the primary materials here, below the surface. At yun ang scope ng litho-geochemistry. So yung word na litho is L-I-T-H-O, di ba? Ano ba ibig sabihin ng litho? It also means rock. What is petro? It also means rock, di ba? So, yung litho-geochemistry was actually coined, no? Mainly to study the host rocks, the country rocks that are hosting the mineral deposits. It is more meant to be used when we are studying the geochemistry related to the formation of mineral deposits in primary rocks as the host rock. Kaya ang litho-geochemistry is specifically used for exploration. Pero when you talk about petrochemistry, it is about what? The origin, nature, distribution, and the magmatic source, no, of a rock. No? It is more about the evolution and history of the rock. Pero when we talk about litho-geochemistry, we are just concerned on the mineral content of the rocks, that if they are related to mineralization. Hindi na siya masyadong nagtotalk about the origin of the magma or the evolution of the rock. Ang tinitignan lang ay they are the hosts of either hydrothermal systems or magmatic segregation deposits. Okay? Or metamorphism, no? Yung contact metasomatic deposits, yung mga skarn. Yun lang ang purpose ng litho-geochemistry, to relate the metal values in the rocks during the formation of mineral deposits. Is that clear, class? What is the coverage of litho-geochemistry and what is the primary environment? I'm correlating them already. Is that clear? Class, nandiyan pa ba kayo?
Yes
Yes po,
po,
sir.
sir.
Okay. So, wag malilito. No, kaya nga ginamit yung lito geochemistry para hindi kayo malito. Yung petrochemistry is more on the evolution, no? Origin of rocks, pero yung lito geochemistry is for purposes of exploration. By sampling the rocks, minerals, and yung mga altered rocks and the ore body itself, or the mineralized ore body, mineralized deposit. Okay, so now let's proceed. Kung ma-clear na yan, so this is again a review, no? GEOCHEM, but what does it mean? Okay, so there is different abundance in rocks, di ba? So this is an example, each element has its abundance. That's why we can classify major elements, minor elements, and trace elements. So if you can recall, ano ba yung major elements? Those that are, what? 1% and above are called major elements. So ano yun? Ito yung mga rock-forming elements that form your major minerals. No? Yung rock-forming minerals. Ano ba yung rock-forming minerals? They are your, what? Feldspars. Ano? Then your hornblende. Amphibores. Your pyroxides. Diba? And then your quartz or silicates that are maybe or the not maybe, and also the excess parts, no, yung talaga SiO2 lang, and the silicates which are distributed, no, in either they can be the amphiboles, the pyroxenes, and the feldspars, and of course the accessory minerals. Okay, so yung mga major elements are those greater than 1%. So ano yun? Aluminum, they are found in feldspars, di ba? Calcium, they are found in feldspars, and also found in your amphiboles, your pyroxenes. Okay, and then here we have another other major elements. Ito, iron, yeah. They're found also in your ultramafic rocks, and also as magnetite, which is a accessory mineral in rocks. Magnesium, ito ay enriched in ultramafic rocks mainly. Earliest to form are your magnesium-rich pyroxenes. And then oxygen, part of the SiO2 kasi siya, silicates. So, lagi may oxygen ka. And potassium for your potassic feldspars. Silicon, ayan, part of the SiO2. Actually, siya yung pinaka-kasama ng oxygen, no? Sa silicates. Lagi sila magkasama. Sodium for your sodic feldspars. And then, ano yung isa? Dapat may isa pa. It's not actually included, but these are your what we call the part of the accessory minerals. No? So yung you cannot avoid, no, na you also these major rock forming minerals, itong binanggit ko, no? They also can form, some of these elements can also form their own ore or minerals as well. Hindi lang naman puro sa rock lang, they can form their own ore minerals. Okay. Now, after the major elements, next are minor elements. These are part of your accessory minerals. Sila ay yung between 0.1 to 1%. Content, no, in a rock. Ano sila, minor kasi hindi siya major, less than 1% to 0.1%. So ano ba yan? Ang common dyan ay yung, of course, yung titanium. Lagi siyang meron yan, no? Titanium. No? it is considered yung mga yan yung spin and titanomagnetite, spin, rutil. Ayan yan, no? Titanium. And then you also have, as I said, yung iron. Part of the iron is in the magnetite as oxide. And also, what else? Included in minor elements are your phosphorus. Ayan, may mga 900, no? Almost. So anyway, class, yung palang 1% is 10,000 ppm. So ito ay 10,000 ppm. So pagka in percent, it is 8.1%. No? Kasi 10,000 is 1%. No? So yan, 81,000. So 8.1% yan. So calcium, 33,000 is 3.3%. Yan yung kanyang abundance na sa rocks, no? Mga rocks. And then iron is 4.6%. Kasi magnesium is 1.7%, titanium is 0.4% kasi hindi siya 10,000. Silicon is 29.1%. Sodium is 2.5% and potassium is also the same, almost 2.5%. Oxygen is 47%. So yung silicon, 29 and 47, yun yung dominant kasi silicates. Okay? And then there are other accessory minerals as well, no? Like yung hydrogen, kasi pagka meron kang water content in your rock, it's moisture, H2O, so nagbabind din siya with the part of the oxygen. And then you can also find sometimes meron ding carbon dioxide. So usually may carbon din na if there is moisture containing carbon dioxide, kasama din usually carbon. And then what is another type of what we call the accessory mineral found in rocks. Usually, ito yung sulfides. Yung mga pyrite natin are sulfides. So, yung iron there, di ba, FeS2. Yung S naman is found together with pyrite. So, yung S is can be part of a it's also can be sometimes as a minor element. Okay? Yun yung examples na why they are minor and trace elements. Also, zircon. Pag may zircon yung ayan, it can be also sometimes accessory, especially in granite. No, zircon. Ayan, they can be found as accessory. Now, the rest of those that are not minor or major elements, they are called trace elements. They are less than 0.1%, or in terms of ppm siya ay 1,000 ppm and below. Okay? Ito 0.1 diba? And below na. At they measure, ito yung mga ppm na yan, no? Yan, maliliit na values. So beryllium is 2 ppm, barium 580. Then here, no, chlorine 130, chromium 100, cobalt, etc. Fluorine 600. Yan. They are all below 1,000 or 0.1%, so they are trace elements. And then there are even much smaller amounts, no, like in here, no, cadmium 0.1%, bismuth 0.1%, and then silver 0.05, and yung gold, saan pa yung gold rito? 0.003, kaya rare siya, kaya ano siya, precious, like the silver also, they're very, very low, and also the platinum group elements. Ito, platinum 0.005, kaya the lesser they are, they have a higher value. Rhenium also here 0.0006. Palladium 0.01. So those are examples, no, of the trace elements. Okay, they're found in the rocks. And then if you try to further subdivide them, there will be different values naman if it is for ultramafic rock. Mafic is basalt, granodiorite, granite, shale, limestone, and other material. No? Ayan, no? So hindi naman lahat pare-pareho. Kasi yung unang table is the average for the whole crust. But this one, if you are able to, these are the results of previous studies that they are able now to determine na different rock types will have some major elements that are higher than the other rock types. So yung ultramafic, as I said, magnesium is the one enriched. Let's look at the magnesium there. So ito, ano? Yan, no? Ultramafic rocks here. Ano yung enriched magnesium? Saan ba si magnesium? Bakit wala si magnesium? I cannot see. Pero magnesium, supposed to be in here. So anyway, bakit hindi wala yung magnesium But anyway, yung enriched is in ultramafic rocks as a deposit are chromite, di ba? So look at the chromite content here, 2,000 in ultramafic rocks. Commonly found is 2,000 ppm. And that is because they are magmatic segregation deposits. Ano pa? Pwede rin iron. Iron is also supposed to be mga type, magnetite bodies are also found. So actually, hindi pala pinakita yung mga major elements dito. Yung iron, major element. So if you go from ultramafic to basalt to granodiorite, nagiging less naman yung content ng chromium, 200, 2,000, 200, 24. Then, halos wala na rito sa 4, granite. So that means different rock types will also preferentially have higher contents of other trace elements. But they are all related to magmatism. Hindi pa kasama yung hydrothermal enrichment. Basic pa lang siya. Okay? And here is the better example here. Yan yung distribution niya, no? If you look at it in a diagram, yan ang distribution of different trace elements. So ito, mga major elements, no? Aluminum, iron, calcium, magnesium. Titanium is a minor element. Yung manganese pala is also a minor element, no? Manganese, no? Manganese. I failed to mention that. So, this is the range of values found in the crust, no? Yung mga range of values, there are some rock types will have higher, while those that, depending on the rock type, have a lower value here, nasa bottom. But the general average would fall within yung pinaka-general range of values are, your common are here found in the white cells, no? Ayan, yung mga elongated cells na white. Okay. So you will see there is also a decrease also in the different types of metals and elements, especially the trace elements become lower and lower and lower, while the major elements are here, no? In terms of 10,000, yan. That is 1% already. And up to, meron pang nag-reach ng 100%. No? That is for pagkano na. Ito siguro, iron. Mga metallic iron na yan. And then aluminum is mainly the clay, no? Maybe that's a form, no? Yung clay, aluminum metal. Okay, so yan yung relative distribution that is found. And then here is again another same example for crustal rocks. Yung nasa average is there, no? In the black dots, almost the same, but this is naman the range. No? So now, what is this used for us, no, in exploration? We are more interested when we are doing exploration. We are trying to find those elements that can indicate presence of mineralization by having higher enriched values. Ito yun. Yung mga nasa upper part na yan yung interest natin for finding, no, what we want to find in our rocks when we like to look for mineral deposits. This can be or be correlated to the presence of mineralization. Diba, what is a mineral deposit? Or it is a concentration of metals no, of interest, economic interest. Kaya, or minerals of interest, kaya you expect they have a higher concentration. Yan yung what we are usually terming as the anomalous. They are already deviating from the average here in this white cell block. Yan yung normal average range, but there are values that are extreme already high, and they are going to be interpreted in terms of being related to possible mineralization. Sabi ko possible pa lang, but normally, yun that's why they become high. There's already a concentration. In the same way here, ganun din, we are more interested in those values that can indicate mineralization, that they are above already the average here, no? There, yung black, yan. Yung average is what we call the background, no? Or the normal value in different block types. Ito kasi average for the total crust, but if you will see different block types also will have their own average. Hindi laging pareho, no, for a particular element. And we are interested in these upper values there as the anomalous compared to the background, the ones here, no, in the black portion. Okay? That's the purpose. In dito geochemistry, we are looking for these values that are elevated or are considered to be anomalous already. That's why we use rocks to sample, no, when we do lithogeochemical exploration, sampling the rocks in the primary environment. Okay? Oh, now let's look at what's the old classification. So maybe you have already studied this, no, during geochemistry. This is the basic classification of Arrhenius. No, it's just talking about the relative, what? Sorry, hindi ko mapalaki. Wait, why cannot I make it big? Ito. Ayan, no? So, this is in relative to the other metals and elements, there is a tendency, no? There is a tendency for minerals to be associated. Oh, diba? Yun yung groupings. So, major elements are these elements, more than 1%. Minor elements, ito, manganese, titanium, phosphorus, even the carbon dioxide because it's moisture. No? And minsan zircon, there, depending on the rock type, but minor elements. And trace elements, less than 0.1%. Ito nasa right. So, here you will see they can be grouped. So, lithophile elements are those elements you find in rock-forming minerals as silicates and oxides. Kaya siya ay lithophile. No? I say lithophile, the rock-forming. They are the dominant. They are composed 95 to 99% of the rock. Ayan. And yung remaining 1%, yun yung minor and trace elements na titira. Diba? So yan ang major, kaya siya dominant in rocks. Rock forming, lithophile ang tawag sa rock, mga silicate siya. Okay? SIO, no? Ayan. But the minor elements are also found there together as accessory minerals, and then the trace elements, depending, some are mineral forming, some are dispersed, but this is a general association. Yan, they associate in a particular type of grouping. So ito, lithophile ang group. Okay. It is more generally rock forming, and then there are trace elements and minor elements or accessory minerals. Now, then the next group is for siderophile, meaning to say they are bound or attracted when there is iron. That iron can be what? Either the metallic iron or can include also the oxygen with it, no? FeO. But the iron is the main consideration also. And you find these other associated metals and elements. There, no? Vanadium, chromium, cobalt, and nickel. And usually, these are the same elements you find, no, in your ultramafic rocks when you have some magmatic segregation deposits. Meron kang chromite deposits that can contain cobalt and then nickel and vanadium. Together with the magnetite, yung iron. Okay? And then the next major grouping is chalcophyll, meaning to say they are bound with sulfur. So since sulfur is not a major or minor element here, in this classification, they are found together with this other or forming sulfides. So, yan, kasi sulfur, these sulfides of copper, zinc, arsenic, selenium, molybdenum, silver, antimony, tellurium, mercury, lead, and bismuth. And also dispersed sulfides of cadmium, indium, rhenium, thallium, gallium, germanium. Okay? That is the one found together with hydrothermal fluids that is deposited. Now, the next would be noble gases, or, sorry, not gases, noble metals. When they say noble, they can appear as metals, you know, in natural environment. They are metals or alloys. Yung metals or alloys are combination of these different metals without having oxygen or sulfur. Wala. They can bind together or bound together or together to form alloys. Sila, nagpa-partner sila or combine as alloys, or they can stand alone as metals. So ano yung kasama? Gold. Very common. Why? It is free gold. That is one commonly found. Sometimes merong electrum, but it is more classified as free gold. Yan. Together with the platinum group elements, ito yun. Palladium, osmium, iridium, platinum. Noble. They can be existing naturally, as metals in the environment. And then these are the other dispersed, but they are also the platinum group elements, rhodium and ruthenium. Okay? Yun yung, we find this in the ores, no? Yung sulfides and the platinum group elements and the gold, no? They are ore forming as well. And then the rest are the found, what is commonly found in the water. These are mostly the one that are found in the seawater. Yan, hydrophil. Together with oxygen and hydrogen. They can form, they are the chlorine, bromine, iodine, and also sulfur as sulfate found in the water. Okay, and then atmosphere is for the gaseous. Noble gases naman siya. So CO is carbon dioxide. It can also be found in the atmosphere. So they are grouped together with this one. Noble gases are helium, neon, nitrogen, xenon, and radon. Astatin yata to. Okay, that is the general grouping because of association. Now, if we talk about mineral deposits in the primary environment, we are talking about not anymore the rocks, no? We are talking about together with the rocks are the mineral deposits formed by magmatic, first by magmatic segregation. They are called magmatic deposits. Ano-ano ba yan? So ito yun. If you recall your MINDEP, they are formed by crystallization during differentiation or cooling of a magma. They are your chromite and magnetite deposits. Then you can also form, because in the magma, if there is a lot of sulfur already in the magma, it cannot mix with the silicate. No, they are immiscible. Kaya ang tawag sila ay immiscible sulfide deposit. No? That means there are specks of sulfide that form together with your silicates. They cannot mix kasi, no? Kaya immiscible. And they are your nickel sulfides, the pentlandite, pyrrhotite, na merong nickel, no? And platinum. Yan, yung copper nickel sulfides ang tawag. Yeah, they are also found together with the ultramafic rocks and the chromite. So meron tayo yan in Akohe Mine, Zambales. There are chromite layers, layered chromite, and then interlayered with them are your nickel sulfide as immiscible sulfide deposits. And then here is you have other crystallization of other types of magmas, and maybe these are in your continental areas. Pegmatites, of course, that is the last stage. Pegmatites are enriched with volatiles, vapors. Sila yung nagpo-form ng yung ating tinatawag na gemstones. Very large crystals, kaya gemstones yan. Of precious value also. Then carbonatites are what? Rich in what? When you say carbon, the carbon-rich magmas. Yeah, and they also form other deposits like niobium is concentrated, and then also sometimes they also are some carbonatites have the enrichment of copper and phosphate. So it depends on the magma type, but it's very rare. Now, from hot aqueous fluids or hydrothermal systems, this is the one commonly found in island arcs and in spreading centers. No? So in island arcs, we have copper, molybdenum, porphyry copper deposits. And then there are skarn deposits, contact metasomatic because of the contact between a hot body or the intrusive magma and calcareous sediments or limestone. You can form contact metasomatic replacement deposits or skarn containing iron, sometimes can have some copper, zinc, lead, and also sometimes there can be gold. Okay. Then there are vein and replacement deposits, and these are your what we call the veins, no? Surrounding the porphyry copper. May mga vein systems. They are also hydrothermal in nature. Yun ang mga tinatawag na mesothermal base metal veins. Okay, they're found around porphyry copper systems. So it's either copper is enriched or lead zinc is enriched, and sometimes they may or may not contain gold in these base metal veins. So in base metal means lower temperature than the porphyry copper. Yung porphyry copper is hypothermal. No? Anong ibig sabihin nun? It is 600 to 800 degrees ang temperature, and then yung mesothermal are 600 to 400. Tapos ano yung epithermal ay mas lower na, magiging less than 300 na yan. Yung other studies show dapat 280. Mas mababa pa yung epithermal system. But it's generally is 300 and below epithermal systems. Okay, then we have hot spring deposits. Yan yung epithermal, di ba? With gold and silver. Okay. And then other types of volcanism that can contain what? Our massive sulfide deposits. Di ba? Meron tayong massive sulfide deposits. Yun yung sa spreading center. Hydrothermal din yung basaltic volcanism, or can also be considered as hydrothermal. Massive sulfide, VMS, volcanogenic massive sulfide. Okay, so ito pala, ito deposited on the seafloor, ito pala yun, no? But the same yan, yung copper associated with basaltic volcanism. They are equivalent to this massive sulfides with base and precious metals. When you say base metal, it is copper, lead, zinc. Ayan. So you have volcanogenic massive sulfides, Kuroko deposits. If it is what? In island arc. Pero yung volcanogenic massive sulfides are in spreading centers. Yung Kuroko deposits in back arc. It's a at the other side of the subduction zone, sa likod na ng island arc mo, merong back arc. Kaya doon ang Kuruko deposits. Okay, may question ako. So, what do you call those deposits that are metamorphosed na Kuruko, na VMS deposits? What do you call that? That's the third type. Yung copper deposits in basalt, they are cypress type. Yan yung sa spreading center, no? Diba yung basalt is formed as the last volcanic layer, no? During spreading cypress type. Pero pag naging Kuruko, ano yan? Yan ay lead zinc in back arc environment like in Japan. O ano nga yung tanong ko? Do you recall what is the deposit na isa pa? The third type? So we have cypress type, Kuruko type. Ano yung third type? Can anybody remember? This temporato, do you recall? What is the third type of a BMS? Napakalam niyo. Ano?
Po, sir. Nakalimutan ko.
Ano? What?
Nakalimutan ko po, sir.
Di ko merong echo eh. Ano yun? It is? What deposit?
Nakalimutan ko po, sir.
So Japanese nakalimutan. Miss Roman, ano natatandaan mo? Yun, Beshi. Yung Beshi, di ba, LGBT yun, di ba? May halo-halo na siya. In fact, joke ko lang yan, pero yung term kasi Beshi. Pero, yung Beshi is a Japanese term for deformed and metamorphosed BMS. Di ba? Ano lang siya? It's a BMS originally but was deformed maybe by movement again by tectonism and then na-metamorphose pa. Kaya siya ay Beshi. And it is also found in Japan kasi in Japan active yung tectonism, yung mga dating Kuruko nila ay na-deformed and then they became Beshi type. Pero even a massive sulfide na cypress type can also be subjected eventually to deformation and tectonism. After transport, di ba nata-transport farther away from the spreading center yung mga massive sulfides on the surface sa sea bottom, doon sila. Pag nag-collide na uli, magsasubduct, they are already, again, subjected to deformation and metamorphism. Kaya even cypress type can become Beshi type. You remember that tinatanong sa board yan, ano yung Beshi type? It is a deformed and metamorphosed VMS. Either Kuruko or cypress type. Okay, ayan. So, as we go on, others are formed by dynamic metamorphism, but we do not have that, no? Okay, yun yung sa primary, no? Very simple to remember, no? Magmatic segregation, those formed by hydrothermal fluids. Ganun lang in general. But there are deposits also na yung mga Mississippi Valley type, yan, yung mga sediment-hosted deposits also discovered, no? Ito yung mga, no? Here, no? They are not obviously related to any volcanism, magmatism, or even the uranium roll type deposits, no? Ano ito? They are formed only in continental basins kasi sa United States, no? And other, in Europe, in China, may mga continental settings, no? Ang ibig sabihin lang, mayroon kang basin na form, tapos through time, because of the weight of the basin, yung bigat, no, of nagko-consolidate na yung sediments, na-squeeze yung mga fluids. So the fluids are squeezed out. And when they are squeezed out, they pass through the layers na porous and then they already start to dissolve, no? The metals and elements until they are concentrated, no, along the flanks. Kasi saan pa ba pag ini-squeeze mo yung yung sponge, di ba? Eh, di ba lalabas yung moisture? Ngayon, imagine, ini-squeeze mo yung sponge pero doon lang sa side ng basin lumalabas. Yun yung mga sediment hosted na lumalabas na siya, yung concentrated metals and elements along the basin, no, sa mga flanks. But if there is a big fault zone somewhere in the basin, when you squeeze the sponge or the sediments, lalabas din dun sa fractures and fault, no, yung mga na-squeeze out na fluids. And then they will go to the surface. Yung sa surface, I mean the surface of the basin, no, maybe it's still submerged in water. Para kami hot spring doon, pero it's not a hot spring, no? It's more of a flow of water containing metals and elements. Yun yung related to sedimentary hosted, no, mineralization, or we call the Mississippi valley type, kasi sa Mississippi nakita, no, yung mga squeezed out. And then it also happens during diagenesis, kasi when there is a compaction, may diagenesis happening, di ba? Okay. Yun lang yung other type, no? What's not all present in the Philippines. Meron tayo VMS, porphyry copper, skarn, base metal veins, epithermal hot spring deposits, and the magmatic, our chromite deposits, nickel sulfide deposits, and some magnetite, minor, no? Doon sa skarn, mas marami tayong magnetite sa skarn, not in the ultramafic rocks. Okay? So, ito naman is when we are talking about secondary environment, pero hindi yan yung topic natin. They are precipitates and what mechanical deposits from the residual material, from the eroded rock and sediments, or deposits na nagwe-weather na, you can redeposit them again in other environments. But this is not our topic today. They are part of your secondary deposits. Deposits produced by mechanical process or concentration, yun yung mga placer deposits. And also the typical along the river or stream, your sand and gravel, they are what we call non-metallic aggregate deposits. Hindi siya metallic, aggregate siya. Or construction materials na siya. Okay, yung placer, ito yung mga those that exist as residual, resistant and residual particles, no, of metals like gold, platinum, and tin, and also yung diamond, which is a high temperature product of metamorphism. Ayan, they can exist, no, in our rivers and streams together with your sand and gravel. Kaya doon tinapan yan, sinasala, ni-screen to get this possible placer deposits. Okay, so that's the review. Okay, to summarize, ito na ngayon yung summary class. So when you talk about rocks that are weathering, ano yung commonly found there? These are your major elements: potassium, calcium, aluminum, silicon, and then there is zircon now that appears, no? And you will see merong association then of these elements: rubidium, strontium, gallium, germanium. That means these metals and elements can replace in the lattice, no, of a particular mineral containing potassium, calcium, aluminum, silicon. May mga nagre-replace na trace elements yung nagre-replace yung rubidium, strontium, gallium, germanium. They replace each other, so you can find them together associated. Yung rare earth elements is a set of 15 elements plus lanthanum and yttrium. Mga yan ang space age modern technology elements. They go together also. And yung platinum group elements, ito yung 6, no? Platinum, lutetium, rhodium, palladium, osmium, and iridium. generally associated. But when we talk of plutonic rocks, ito na. There are other associated, what like that is ito, doon sa Arrhenius na classification for dito 5 elements. Ito yung mga pwedeng found together with these major elements. May halogens na, and also the rare earths can be found, including some tin, niobium, tantalum. They are found in granitic terrains. But these other elements are found in ultramafic rocks, itong vanadium, chromium. Diba? Okay, in uranium, thorium, hafnium, they are found in granitic rocks also, no? Yung that have radioactive minerals. Okay, ayan. Yan yung mga general association. Now, if we talk about rock type itself, yung rock suite is kung natatandaan niyo yung petrochemistry nyo, no? You can classify magmas also, no? In what is the dominant elements that can form calcic rocks, alkaline rocks, mafic, and ultramafic rocks, and pegmatites. Ito naman yung kanyang association. So when you say felsic, they are rich in sodium, potassium, and silica. Alkaline is what? They are rich in alumina, sodium, zircon, titanium, niobium, tantalum, rare earths, phosphorus, and fluorine. Alkaline siya. Alkaline rocks. But actually, yung alkaline rocks can also contain potassium and sodium, di ba? Actually, kasama yun. Yung potassium and sodium are important when you call it an alkaline igneous rock. Mafic igneous rocks, we already know about that, and ultramafic. Kaya magkasama lagi. And then, pegmatites that form your gemstones, ito. Yan, yung lithium, beryllium, boron, they cause decoloration of your gemstones. Rare earths, niobium, tantalum, and then some pegmatites also contain uranium and thorium. Contact metasomatic, they can contain tungsten and tin in continental areas, and maliit din also in continental areas. But in our case, in the Philippines, we have island art. Contact metasomatic deposits are richer in copper and iron. Okay, and so on and so forth. Sedimentary rocks. We have a combination of most of these things. Why? Because they are the eroded materials from these other original rocks. No? Kaya they are combining yung sedimentary rocks, yung iron oxides, manganese oxides, phosphorite, black shales. And look at the black shales in itself. No, it is a very enriched layer. It has a lot of other metals and elements. Kasi nga they are already part of the secondary na rock yan. Ano na siya, yung na-recycle na yung mga elements na coming from the original eroded rocks. Okay, now I'll talk about what is the basic principle now to explore using geochemistry of rocks. Or even not only in the rocks, in the future when we talk about even in the soil, in the weathered rock, doon sa secondary environment. Ganito din yung operating principle. It's very simple. What the geologist wants to find is the presence of this dispersion pattern. Yan yung gusto nating hanapin in our samples. Kasi when we plot the results of our samples in a map, we can see a dispersion pattern. That is a pattern of increasing concentration of the material, of elements in a material that we sampled. Okay, saan ba galing yung dispersion pattern? It is starting where but the transport of these metals and elements when they are removed or they are mobilized by magmatism or hydrothermal fluids. Ito, yun ang mobile phase nerve. Diba? In porphyry copper systems, hindi naman form yan kaagad from the magma. Hindi lahat galing sa magma. Some of them have been contributed by the circulation, yung kilometer-wide circulation of these hydrothermal fluids, and then in the process of circulating in the country rock, they are dissolving already some of the metals and elements in the country rock in the hydrothermal fluids they are transported, no? And they are eventually deposited again, no, as other minerals, no? Yun yung alteration minerals or secondary minerals in the surrounding area of the surrounding area or in the boundary of the main or mineralization. They are included there. They are enriching also. Kasi hindi lahat ng porphyry copper galing sa magma yung metals. Some of them have been introduced by the circulation of the hydrothermal fluids. So this process is called the dispersion process, and it is up to the type of fluid that is the one transporting it. It can be the magma or the hydrothermal fluids or the metamorphic fluids. As long as when they are transported, they are again redeposited or precipitated with other minerals in the another site or in another area away from the source. Diba kasi tinatransport siya, merong iba, they can go farther away from the source, or they can go farther away from the fracture or the or concentration. Ganun yung nature, no? The fluids can travel farther if there is permeability, porosity, or fractures present. And everything there is called the dispersion process, meaning to say the dispersion of the metals and elements from their original site. And if the original site is your mineral deposit, or even the altered zone containing some elements also, you are able to transport them away, and then they are deposited in another area, which the geologist is trying to look for. Kasi yun ang guide natin. That becomes our guide. It is what we call the geochemical pattern, dispersion pattern, as our basis. And it becomes our guide or our tip, yung clue to finding eventually saan lang galing ito. We have to follow the transport pattern, yung saan siya na daan, and eventually we will find the source. So ang trabaho natin, sample different materials in an area, and if there is a dispersion pattern of high values, then we start going back. That's why, di ba, ang exploration phases are apat. So ganun, you start with regional sampling, semi-detailed, then detailed, and then drilling na yung final. Ito yun. The same way, we started from finding regional dispersion patterns, and then district or smaller area dispersion patterns, and then we have become site-specific already areas of high values. Ito na yun, yung narito na sa source, papunta tayo rito sa source until it is the ore body itself that we are able to sample, no? By drilling. Yun yung phase 4, if you remember class. So we can relate everything here to the dispersion pattern process, yung different bases of exploration. So as long as we can find the dispersion pattern at the start, that's the chance we have, no, in finding a possible mineral deposit. If we cannot find a dispersion pattern, that means two things. One, maybe there is no mineral deposit in the vicinity, or we just lack more sampling. Hindi natin natamaan or natsambahan. Kasi, by the way, class, no, there is one more element in discovery, no, which is not put in scientific journals. Pero lack, no? If you ask any geologist, kailangan meron ding luck present, no? Yung chance mo is higher if you have luck, swinwerte ka. It's not written. But if you read yung mga experiences of mga old scientists and exploration geologists, no, yung they consider luck, as one of the important factor. Pero hindi natin mailagay yun kasi it is an unscientific term to be used. More of diligence and hard work ang gusto nating emphasize, and that means do more sampling and interpretation. Okay, do you understand this very basic logic that we are doing in exploration? It is starting with the dispersion pattern and then we follow it back to the source. No? And that dispersion pattern is represented in a geochemical anomaly map. At yun yung magiging project nyo. We generate our own. Each one of you will be assigned a data set. You will generate your own dispersion pattern or geochemical anomaly map. So you will learn this actually in this subject, how to make that anomaly map. Okay? Oh, any questions here? The simple logic and method of exploration using geochemistry. Meron pa bang gusto magtanong? None?
None po, sir.
Okay, sige. Oh, yung mga ginigising ko kayo, baka tulog na yung iba. Oh, kasi next week mag-short quiz tayo, kaya ito yung scope ng work, yung Lito Geochemistry scope of the very short, 20 minutes. Pero kasama itong Lito Geochemistry and yung phases of exploration, yung what is an ore, yung last natin na lecture, yung lecture 1. Tsaka yung ore, about ore, definition of ore, PMRC, and exploration phases. So, this will be also be part itong Lito GEOCHEM. Okay? So, since no more questions, so I go back now to the classification here. So, ito yung textbook classification. Deep-seated is your primary. There. Kasi nakakalito tayo. And then superficial is the one on the surface, secondary. Okay, kasi tingnan nyo na nakakalito. There is, in the superficial, you have primary and secondary. And lalo tayong nalilito. Diba? So, for our purpose, to make it more simple, when we talk about the environment, it is the primary when we talk about the country rock around an hydrothermal deposit or a magmatic segregation. Kasi tignan nyo yung secondary niya. Diffusion of metals from ore deposit undergoing metamorphism. Pero yung metamorphism is the same as hydrothermal fluid. It's also a fluid or contact metasomatic fluid that also cause demineralization. Pero they are all in the primary environment, yung deep-seated. Kasi yung gamit lang ng primary and secondary, dapat ito ay primary and epigenetic. Hindi niya ginamit yung word na epigenetic, diba? It is after the formation of the country rock. Pero tawag niya lang secondary, kaya nakakalito. So, for our purpose, we understand each other. When we talk about deep-seated, it is the primary. Whether it is metamorphism, hydrothermal, or magmatism, primary yun. And then the superficial is anything exposed on the surface. No? Yan, weathering, and then yung precipitation on the surface also of the seawater, yung primary, secondary din yun. No? It is the zone of above the surface. Okay? Yun lang, no? I wanted to make sure so that you will not be confused by this table. Kasi dapat epigenetic yung term, no? Ang ginagamit. Okay. Now, let's start to look at, class, this is the start of looking at patterns. No? So, let's start with the simple. So, this is a vertical profile of an ore body. You want the one to your left, no? 500 meters. Then you have a primary sulfide vein there. This is a vein. Yan, yung black line at the center is a vein. But the concentration of mineralization is here in this portion around 250 meters. No? Now there. Yeah. Okay, you will see also here, no? There is what we call the alteration halo. Ito yung mineralogical, petrological halo. Hindi yan GEOCHEM. No? You will see that the other bold line. Yan, class, no? Kita niyo yan? Bold line siya. So in there, it is defined by yung alteration minerals. No? Hindi siya GEOCHEM. Okay. Kasi alteration halo. Around the vein. Okay. And then, when these were analyzed, no, let's say, in-analyze yung content, no, surrounding this vein, yung kanyang wall rock ang tawag, no, on both sides. The one at the right is the foot wall, yung nandun sa taas is the hanging wall. Yung ibaba, itaas ng inclination, no, yung is the hanging wall, the one on the other side is the foot wall. So, in-analyze yung mga metals doon, no, sa wall rock. Rock ito, rock. Okay, they found out that the alteration halo also is equivalent to high concentrations of copper and zinc. Kumbaga, nagko-coincide. Okay, the alteration halo is also the copper zinc halo around the vein. Yan. Okay, and then when they look at the lead, yung lead is contains the almost most of the concentration of the deposit here, no? Yan yung ito, yung malaki ito pala. Ayan, no? Do you see this? Mas kita na ba yan? Plus, yan, no? Yung lead contains the three-fourths of your upper part of this core zone, and then it is even found, also above. Ganun yun, no? It is because lead has been dispersed, no? Transported further, no? Above this layer, this or body. Kaya malaki yung dispersion pattern niya. Okay, I'll introduce three words, no? Yan ang tinatawag dito sa mga pattern, no? They are called your envelope, your halo, or your aureole, A-U-R-E-O-L-E. Ayan, British term siya, no? Aureole, and ang halo is English terms, pati envelope. It's easy to understand. Ito yung surrounding, no? Naka-envelope, naka-halo, or aureole. Yung halo naman is just like yung mga santo, di ba? Yung santo meron siyang depicted as having a halo on the head to show he is a saint, no? Ganun din, no? Halo din ang tawag when there is an envelope surrounding mineralization or the ore body. But you will see here, no, yung barium, so yung lead encompasses the bottom, the upper three-fourths, and then even extends up to the vein, no, up there, no, along that fracture. The barium only touches a portion of the uppermost part of the mineralization, and it is not wide, no, it is thinner than the halo of the envelope of your lead. Okay, but the copper zinc encompasses the top, the bottom, and the main or body itself. So parang ang copper and zinc have a wider dispersion halo or pattern, while the lead is also partly overlapping, and the barium is only in the upper part and much thinner surrounding the as envelope surrounding the vein. Now you look at the copper, this cobalt molybdenum. They are found at the lower half, but it's extending further down along the vein fracture. Okay, so what does it tell us? Very simple. It tells us that different metals and elements, no, when they are dispersed around the ore body, have different dispersion patterns. Hindi pwedeng lahat magkakasama. That also means they behave differently during the transport of these metals, no? But since this is a vein, it is a hydrothermal fluids that are able to transport them away from the source, the ore body, but it is more widespread yung copper and zinc, and then much less yung lead and barium, but they are found only in the upper part, and then the copper moly is mostly found in the lower part, but also a bit widespread yung cobalt moly dispersion pattern. Okay, so yun, different metals and elements will have their different dispersion patterns, and some can be the same. Some can be correlated with the the halo. envelope. Okay? Yun yung isa. Basic principle. Not all have the same pattern disposed around the core body. Okay? Next, let's look at this other figure to the right. Ito. Okay, do you see this to the right? Let's look at it. These are different elements again. So this is a folded. Ito, Beshi type to. Folded, folded ano to, no? Deformed and folded VMS, no? Kaya kita nyo, no? Tingnan nyo, para siyang ano, no? Deformed na siya, no? Hindi siya straight layer, hindi siya lens, no direction, it is a bit folded. Yung dark color, no? That's the ore body. So, ayan, BMS, deformed, folded pa. Ayan. Okay, so you will see, for antimony, ito yung dispersion halo niya, ito yung mga dotted, no? Patterns. It only encompasses the upper part, generally speaking. Nasa upper part, upper half, and very thin. Okay, next is cadmium. It is more dispersed, but it encompasses the whole ore body na VMS, but it is also partly scattered around. So merong mga portions na may mga high values na nakarating pa yung metals and elements. So it is more, the cadmium is more, travels more, no? Farther away than the antimony. So ganyan na nature, you cannot always have a perfect continuous pattern. There are patches or portions around, no, the ore body. Okay, then when we look at the lead, yung lead, the lead has a much wider envelope, and it encompasses the whole of the VMS. Ayan. And it then extends downward, yung lead yan. Sa VMS to, no? Yan. And silver exhibits the same pattern. It is the same, no? It is what we call correlative to the lead pattern, almost. Diba? We got the same, almost same pattern, and also the more wider envelope. Yung spread of the envelope is also wide for the lead and silver. Now here, we look at this one, the cobalt and the tungsten. So in cobalt, encompasses only the lower part na. Here, lower half, there, no? And it is a bit closer, no? It does not have a very wide dispersion pattern. But here is the tungsten. You will see, yung tungsten is not found even in the ore body. It is found at the bottom already, just close to the ore body. So that means yung tungsten, ang tendency niya ay hindi siya nagta-travel upward or transported upward. It is more found in the bottom part, separated already, almost close but separated from the, it does not even overlap. Okay, so what do we learn here? So aside from different elements have their patterns, no? Okay, not all elements necessarily will overlap the whole mineralization o deposit, because may iba-ibang behavior sila, or what we call their diffusion. That is nature, no? But of course, there are, yung involved dyan ay yung kanyang mobility. Yun yung term that you will learn, no? Is the mobility. How far can it go, and also what are the conditions to allow it to be being transported further away. Okay, so yun. No? These are your anomalous envelopes ng different elements. So I have a basic question here na, class. Two questions, no? So what do you select now if you are doing sampling in the, let's say we're doing semi-detailed, no, meaning to say we are already in the area, no? And then we are doing sampling every 100 meters na, no? Diba? So, anong pipiliin natin ipang interval mo every 100 meters? Do we select antimony and cadmium, or do we select lead and silver? Kung ano na tayo, nagsasample tayo ng rock on the surface. But who can answer that? wants to try? Anong pipiliin mo? Antimony, cadmium, or lead silver pag nagsasample ka ng ano? Let's say yung ano mo, yung 100 meters mo ay ito. Ito yung distance niya, yung ano, itong 1/2 of this, no? Yan ang ano, 100 meters. So ito 200 meters na yan, no? For example. So anong pipiliin mo pag to sample? Anong element, no? When you are doing every 100 meter interval. Okay, of course, what we want to choose ay yung dispersion na wide para may chance tayong tamaan. Kasi we do not actually see what is at the, hindi natin nakikita yung below the surface. No? We do not actually know where they are. No? But if we can sample every 100 meters, ang i-analyze natin yung mga elements that have a wide envelope like lead and silver. Yan yung pipiliin natin kasi there is a chance we will hit, no, a portion of this, no, yung silver or lead envelope while we are sampling on the surface. Kasi sabi ko semi-detailed, di ba? Okay. Now, if we are already doing detailed, pag sinabing every tens of meters, therefore, then we can choose cadmium and antimony kasi mas closely spaced na yung sampling, we will have a better chance also. We will definitely hit, no, a portion of this cadmium and antimony anomaly. Okay? Ganon yung decision making dyan. No? What elements to analyze depending on the interval. We choose at the start, we choose to sample but analyze elements that have a wide dispersion, or they are able to be, they were transported farther away from the, or diffused, no? You dispersed or diffused farther away from the ozone. Okay? Oh, ito na may next question. Oh, let's say, nag-sample tayo sa field. And then, ang na-analyze natin, uy, merong high values of tungsten, yung W. No? Ano ngayon yung interpretation nyo? Do you want to go back to that area? Nakakuha kasi ng high value ng ito, nakakuha ka ng high value of tungsten. Let's say ito na yung ano mo, no? Ito na yung nakukuha mong value when you did your sampling. So parang ano na, yan na yung pick up natin sa sampling. Okay? Do you want to go back there? Pagka ang tungsten mo mataas, na anomalous. Sino gusto magsagot dyan? Oh, Bising. Who wants to give a try? Miss Roman, mag-try ka nga. Ano gusto mong isample dyan? What do you interpret? Pagka anomalous tungsten na ang nakukuha mo sa sample mo? Do you want to go back there? Maghahanap ka pa ba ng deposit? Yes, correct. Why? Kasi, why? It is because what? Kasi, malamang ano na nangyari. Kung ang nakukuha mo na lang yung tungsten anomaly, is because what? Kasi eroded na yung ano mo, or body mo, kasi you only find anomalous tungsten dispersion at the bottom. Okay? Di ba? Ibig sabihin, yung sampling ano mo, level mo, ay narito na. Narito na siya sa level ng tungsten anomaly. Meaning ko sa eroded na yung dati mong or yung deposit mo na ano, VMS. Okay, we can only do that if we have a model in the area. So we study previous exploration work and their dispersion patterns so that we can use them in our own exploration in the area. Meron kang model na sinusundan. Ito yung model. That's why we choose for intervals, yung widely spaced if you are doing semi-detailed every 100 meters. Pagka detailed ka na, we can choose antimony and cadmium kasi they are close na. No, they are close beside your ore body or your ore zone. And then there is also a difference also in elevation profile. Vertically, merong mga elements na not actually covering the ore body itself. Some are above, some are below. And especially for tungsten, very clear, hindi siya part na ng, wala na yung ore body mo if you are getting high values of tungsten. No? Kasi, meaning to say, na-erode na yung upper part where the ore zone was supposed to be. Okay, ganun yung pag-apply nito mga figures. Okay? So anyway, before, noong mga early 1970s, ito na yung mga typical, what we call the elements used to detect, to be able to help detect mineralization. So arsenic, boron, mercury, molybdenum, it depends on the type of deposit. These are generalizations, of course. No? So different type. They are mainly from continental areas. No? Yun yung, kasi doon nag-i-explore ng karamihan before. Okay? Different metals have a pathfinder element. When you say pathfinder, it means a guide. Di ba ang pathfinder is a guide? Yung path is a didaanan, yung trail. So kung meron kang guide sa fieldwork, yung trail, sinusundan niya yung trail, alam niya. So, kaya finder siya, pathfinder. Or for GEOCHEM, yun yung guide for finding the mineral deposit, pathfinder. Okay, but this is just a general use of that, no term na pathfinder. But now, I will go to the actual, ito na, yung part of your assignment. What is the actual definition of a pathfinder and a what a indicator element? No? So, based on studies of all different exploration companies and work by government institutions, so did also exploration in the different parts of the world. Eventually, they compile this table, no? Depending on the type of deposit, what are the indicator and the pathfinder elements. Okay, so in your research, di ba nakita nyo parang magkakahalo yung pathfinder, no? And indicator. Di ba? Ganun yung unang concept kasi anything that helps to find the dispersion pattern of coming from a mineral deposit, pathfinder siya. However, there is the more definite definition now of what is a pathfinder and indicator. Kumbaga ito ay na-improve na, no? So it is more meaningful to the exploration geologists. Okay, when you say indicator, it is the major component that has economic value. You are mining it because of that element or metal. Yun yung may value, yun yung binibili na product mo eh. It is the major component of your ore. It is called the indicator element. So for example, in this case, so yung magmatic deposits, yung chromite ores, di chromite yung indicator niya. Kasi yun ang major component of economic value na gustong ma-extract sa mining. Yun yung nagbibigay ng value, the chromite content, yung resource niya. Indicator siya. Now, those that are associated with the ore body, but they are not the main economic elements of interest, but they are the helpers or the guides for exploring the ore deposit na chromite. These are your pathfinder. Ito ay yung nickel, iron, and magnesium. Okay? So pathfinder is not anymore including the indicator or yung major component of the ore. Yung pathfinder are other associated elements na hindi siya economic. Ang merong economic value ay yung chromite. Kasi yun yung kino-compute ang resource and concentration, yung average grade and the volume or tonnage of the resource. Pero meron siyang associated, meron din siyang concentration but not of economic value to mine. Pero kasama siya. You can also recover that as byproduct, but it is not the main purpose of mining. It is the chromoid. Okay, so for these different types of deposits, you will see, yun lang may economic value are the ones in the indicator. So let's go through it. So in the Philippines na lang, anong meron? So we have, as I said, yung copper nickel sulfide in Akohe mine, mga nickel sulfides. So copper, nickel, and sulfur. Yung copper and nickel are extracted from the sulfides. Also the sulfur, kasi yung sulfur ginagamit to prepare laboratory grade sulfuric acid. So may value siya. Nagagamit at nasisell yung sulfuric acid as a product. Yung nickel and copper are both binibili siya ng isang company to be used in their smelting plant, or they recover it, whatever is needed, yung copper and nickel. In the same way, some deposits also have recoverable platinum, nickel, and copper. Yan. They are the same. They are also copper nickel sulfides, pero meron naman siyang platinum. So kasama siya sa indicator. They are the ones earning for the company, yung binibili yung value pati ng platinum. And then the pathfinders here are to the right. Ito yung walang economic value, but they are used for exploration. They are the associated metals and elements. So here, you will see, dito sa copper nickel sulfide yan, na deposit, pero yung platinum meron. It's not naman used to, wala siyang enough economic value, but they are associated. Kaya naging yung platinum, naging pathfinder na lang siya. No? Together with the cobalt, arsenic, even the gold is there. Pero wala siyang, hindi siya concentrated enough to give value. Kasi kaya lang siya, guide for exploration. Meaning to say, you also analyze your rocks for these elements kasi you want to determine also the pattern, like what we saw, yung pattern na ganito, to see which has a wide dispersion or envelope, and the ones that are close to the ore body as our guide or model in the future when we are looking for other similar deposits in the area. Okay, so what are the other metals deposits that we have? Porphyry copper, we have this, and molybdenum is just a pathfinder, but we have one deposit that is molybdenum. Molybdenum naman ang naririto, no? Siya naman yung major component, no? Indicator siya. Yeah. Tapos, tingnan nyo, yung copper naman yung naging pathfinder, wala kasi siyang economic value. Ito, may economic value, yung molybdenum and sulfur, copper and sulfur naman sa isang deposit. Okay, so it is interchangeable. If you are not a major earner or you are not the economic value to earn for the mine, you become, that element just becomes part of the associated and is a pathfinder element for exploration. So in the Philippines, we have this iron magnetite. Yan. So iron, what is recovered and sold to the buyers, yun ang may economic value. But the copper, cobalt, and sulfur that are just associated, they are called pathfinders. So we also have copper iron skarns. Also, not only iron, meron din yan. So the copper and iron and the sulfur are the ones that have economic value. Yun ang mga content yan ng gold and silver, they become pathfinders. Ito namang skarn na lead zinc, they are found in continental naman yan, settings. Kaya lead zinc naman siya. No? And yung copper cobalt naman ang pathfinder. Yung base metal veins that are found, no? These are your mesothermal base metal veins found around the porphyry copper system. Dun sa sides and sa above it, kaya mesothermal siya. They have lower temperature than hypothermal. Ito yun. When you say base metals, it is composed of copper, lead, zinc. Kaya base metal. And then sulfur is also recovered at a profit. And then the rest of the associated elements, gold, silver, arsenic, antimony, and manganese, they are pathfinders for exploration purposes. For epithermal and precious metals, Gold, ito yung ating gold deposits in the Philippines, gold, silver. Usually may value, but look at the other metals and elements that help find them. Antimony, arsenic, mercury, tellurium, selenium, sulfur, and copper. Then mercury deposit, we have that in Palawan, yung Palawan Quicksilver Mine, pero closed na siya, abandoned na siya. Dati, it was mine for mercury and the sulfur. Ano ba yung or mineral na HG test, no? Ano yun? Orpiment, realgar, no? Yun yung mga mercury bearing sulfides, di ba? And then the pathfinders without value, it's antimony and arsenic. Actually, yung mercury is also like an epithermal deposit. No? Hot spring din yan. No? Kaya yung arsenic and mercury, yan yung toxic I was talking about in our environmental geology definition. No? Yeah. Epithermal deposits in hot springs, they contain mercury and arsenic. Yan yung nakakarating sa food chain or the water supply na dapat iwasan. Then, VMS, ito, copper sulfur is for cyprus type, no? Volcanogenic, volcanic associated massive sulfide na copper, cyprus type. Pero meron siyang zinc, gold na hindi siya economic. They do not have too much concentration to become economic. They are pathfinders. Ito namang BMS na ito yung base metal then also, no? Because it is copper, lead, and zinc. And they are your Kuroko type. Yeah, no? So it is your copper, lead, zinc, sulfur, and then these are your pathfinders without too much economic value. Hindi siya sold, no? But they are used for exploration. Okay? Yan sa primary environment. Now, I just add one here for secondary environment kasi sa Philippines, you have to remember, no? Yung ating bread and butter today is our nickel laterite deposits kasi we have a lot of these. There are around 26 nickel laterite deposits, no? That the Philippines is earning. So we recover nickel and iron sa laterite. We will learn about this later. And the byproduct there is cobalt, vanadium, and chromium. Pero today there is an added value. Yung scandium, which is a rare element, ay nare-recover na. That was 2 years ago. Nagkaroon na ng special plant. Yun yung Coral Bay HPAL, high pressure acid leach. Yun yung HPAL, high pressure acid leach that can recover the scandium from the iron-rich laterite. Hindi siya nickel-rich but iron-rich. Meron scandium. It becomes an indicator element. It has a value already when it is recovered. Okay, so we'll talk about that again later. Class, you will see now what is the meaning of indicator and pathfinder. Indicator means the main component of economic value. That's why you mine the deposit. While all the other associated elements that do not have sufficient economic value are relegated to pathfinder. But they are still helpful when you plot their dispersion patterns to be able to discover the deposit or the mineral deposit. Okay? Yun yung totoong definition. So I think several of you have used this table. Kaya lang yung iba, they did not anymore classify, no? Like this. Kaya nagkahalo-halo din yung pathfinder and indicator. And yung iba, they even talk about the sequencing, no, of this pathfinder and indicator elements. Kaya lang, nagkahalo pa rin sila, which is the actual indicator and which is the pathfinder. Okay? Yung paragenesis ng elements naman ang diniscuss, pero hindi yun. It should be the indicator and the pathfinder specifically. Okay? So that now is a understood. No, so now let's look at how now let's look at other dispersion plots. No? Okay, so yung pinaka-simplest to understand here is like this class. If you have instead of plotting in a map, you look at the profile. No? So meaning to say, distance away from the mineralization, ito. So you will see this is the distance away as you go away further from your contact with the ore body. A particular metal or element, for example, this one is zinc, there is a decrease or decay of your values as you go away. No? So your dispersion pattern is increasing naman towards, of course, where you have the ore body kasi logical, no? When you are nearer, it becomes higher also ang value mo. Especially if it is already inside the ore zone, that will be much, much higher. But in the dispersion pattern or decay, there is a distance, no? That you can see what is, you can treat as your yung width of your dispersion. So ano yung width of dispersion here? So if you look at this, ito yung zero dyan, value, halos normal value of zinc, that can be your background. Wala siya lang talagang high value of zinc, no? In this rock type. Ito yung country rock. No? Pero when you hit 50, 45, when you're 50 away, meters away, and then 40 meters away, 30 meters, 25, you already have an increasing of concentration of the zinc in the rock. So effectively, you can say, no, if you ask me, I will choose this 40. No, why? That is the effective, no, width of your dispersion. Why? Because this value here at the 50 is still too close to the background, just above zero. So that can be interpreted as what? Maybe it's an error in analysis or introduction of contamination, but it's still too close, no, to the background. Kaya usually, this can be disregarded. No? Yung mga malapit na, very close, kasi it is, it has maybe just a 50-50 chance that it can be a part of the dispersion. But when you see these higher values, you can say that the pattern, no, the dispersion envelope has a width of around 40 meters, no, effectively. Okay, that's the simple one. Look for elements that have a dispersion width, no, as much as possible, na is wide. So you can easily find, no, where the direction of increasing value is. Okay. Here is the same pattern. It's now arsenic, no, in sandstone, no. This is a gold vein, but arsenic was used as the pathfinder. No? It's not the indicator element. So there's your vein. Of course, you will expect very high concentrations of arsenic. That is 1% already. Arsenic in the vein material between 0.1 to 1% values. No? Yan. Of course, yan na yung ore value. But as you go to the left, there is also a decay, no? Or a pattern, no? Between 0 to maybe that's 5 meters. No? There, no? Kalahati nito, 5 meters. That's the effective lang, no, na envelope of your arsenic here on the left side. But in the other side, your arsenic is still high, no? Even beyond the 5 meters, maybe up to 10 meters or more. Meron ka pa rin high value of arsenic that could be considered as anomalous. Kasi ito yung background mo, no? Near 0 or 1. 1 mataas. It's around 100 pa rin or 80, 70. So what does it mean? No? There is no standard distance, no? For a type of deposit. It is not uniform always. Your spread of dispersion or yung width of your dispersion. Any deposit will have its own different dispersion pattern and width for different elements. Hindi lagi siya na-fix na pag 45 meters lang dito sa isang side, 5 meters din sa other side, no, of your mineralization. that is nature. Maybe can be explained. There are more fractures and permeability in the right side. That's why the arsenic was able to be transported much farther away. Then here to the left, medyo tighter yung permeability or there are less fractures. Kaya hindi na travel away, no? Yung dispersion ng arsenic. There are geological reasons, of course. But that, as I said, is nature. Hindi ka rin kasi uniform yung conditions surrounding a mineral deposit. Okay? So yung patterns will have different shapes. No? When you plot in a map, pag map naman, you will see it's different shapes and patterns. Hindi lahat, they are equidistant. No, they are not equidistant. Okay, here's a more complex one. No? Here is a arsenic again, but it is a shear zone. What is a shear zone? It is a highly fractured portion of the rock. Diba? Ayan, you will see. Oh, kaya siya highly fractured. Di maraming openings, so the arsenic is able to fill in portions of that opening. No? So that shear zone has the highest value, but as you go away from the shear zone, nagkakaroon ng decay. No, nagiging less and less, so that means there is less transport of your arsenic in this. Other, the right side. No? But here, there is a immediate rise. No? So meaning to say, it's not fractured itong left side, kaya wala pumapasok na arsenic values. But in the other right side, there are more fractures also, or less openings, and they still allow the dispersion of some of the values of your arsenic, kaya nagkaroon ng decay. No? So here, a mineralized shear zone, no, can be wide, but at the same way, no, you cannot expect the similar pattern, no, around it. So itong mineralized shear zone means hindi ka magiging specific ano yung talagang main ore body mo. You can treat the mineralized shear zone as the whole ore body itself. No? But in between, there are portions that do not contain the ore. No? Kaya lang, as a zone, it is a mineralized zone, or that is their mineral deposit based on these high values. But the erratic naman yung nagiging value because different, there are portions that are not mineralized completely. Yan. Okay? So, ganun. By nature also, there will be different patterns even in a mineralized shear zone. Now, here again, here. So here, lead naman ang inanalyze sa surface, nagsasample, but it is become more complex. So this is jointed. It's the same as a shear. No? Shear zone is also similar to a jointed rock. So yun yung mga portions in the joints that are mineralized. So when they analyze the value of lead here, no, yung mga mineralized joints, they are the ones giving the high values. And in between, there are low values na unmineralized, kaya mabababa lang, no? They're slightly mineralized. So again naman ang pattern is a spiky pattern. Okay, but now here comes the complexity. In exploration, you do not just look at the pattern on the surface. You have to understand is where did this mineralization come from. So if you understand the stratigraphy and the structural geology, you can come up with a model like this na kasi jointed lang yan, nasan yung main ore zone mo. No? So if you know the stratigraphy of the area and then it says in your stratigraphy, it is this layer, the Carboniferous limestone that actually contains the ore zone, the more economic ore zones, then this is just a guide on the surface. It's just indicative, although you saw the mineralized joints, you know it is not the main ore zone. They are just representing the sites where the transport of this lead coming from your mineralized ore reach the upper part of the stratigraphic column kasi fractured siya. So that is where you will now make an assessment. You do geophysics, you study paano nagkaroon ng fracturing and saan nakakonect yung fracturing until you are able to come up with a model to say This came from a solution channels, no, that are directly related to the actual source of the ore. So, nung na-deposit yung ore, meron na rin solution channels diyan, nakarating yung lead. No? Maybe the hydrothermal fluids reach this layer, millstone grit, and into the jointed, enter the jointed fractures, spaces in your upper layer, no? Millstone grit. So, ganun, it becomes more complex when you do exploration. It's not just on the surface. You now have to interpret it with respect to structural geology and stratigraphy. This is very important, no? How do you learn this? You learn them from your research, and also you imagine paano nakakagawa ng model. It is by bonding with your fellow geologists who have also worked, no, in these areas. Kasi maybe in their area, they have this carboniferous limestone and shale. Wala naman sa kanila yung millstone grit. That is in your area. So when you're able to discuss and correlate different settings or configurations, then you can it's like a jigsaw puzzle. You can eventually be able to make this picture. Then you can explain to your boss, we have to drill and do geophysics to find the actual source of these mineralized joints. Ganun ka, nagiging more complex, di ba? From a simple profile, it now becomes more complex if you do add the structural geology and the stratigraphy. In fact, no, most of these are learned, no, when you do, as I said, nagbabanding ka. Yung mga previous times, no, yung mga geologists here in the Philippines, they also, during break time, yung kanilang yung weekly break or yung schedules nila, they are working for different companies, but in a general area, they usually, asa pa ba magkakaroon ng ng social life unless mga geologists din nakikita-kita, and then they discuss these things, geology, over food and drinks, no? Iinuman, and then geology pa rin pinag-uusapan, at dito lang nalalearn, no? By just socializing and discussing geology with your colleagues. So, ang advice ko, pagka nag-work na kayo, maybe in the future, huwag kayong magkaroon na break in your contacts, no? Kasi eventually, you may need each other in interpreting an area, no? When you're doing geological studies or exploration. Na makakatulong yung learning from the other surrounding areas, no? Kaya important na laging meron ding connection with other geologists. You cannot solve everything by yourself. Okay, so here's another example. Ayan, profile again. So ito, single channel lang to, no, sa right. No, there is a leakage halo. Ito yun. Yung leakage is the same, no? Nagkakaroon ng escape, no, yung metals and elements. So if there is no halo here, there is no chance for you to the halo is so small. If you are sampling even every 100 meters, no, on the surface, you will lose the chance, di ba? Ayan, mahirap. That's why luck is involved. No? Unless you're sampling every 10 meters or 5 meters, there is a chance you can hit it, but there is also a chance you may not hit that specific halo, the fracture, di ba, class? No? Yan ang mahirap. May luck involved. But if you are working like this, no, malaki yung leakage halo, they are lucky. Even you sample every 100 meters, there is a chance you will sample some of this leakage, and then you can interpret, no? It comes from somewhere below, and what is that favorable source, no? And then you study the stratigraphy, structural geology, again, like the one before. Now, how do we solve this problem of very, very small chance, no? So, maybe it's not anymore sampling the rock. Ang ginagamit ngayon dyan, class, is if it is a epithermal vein, they use a mercury analyzer na nakabackpack, no? Portable mercury analyzer, lalakad lang dyan sa surface, no? Every continuous walking, and then the analyzer is able to detect mercury vapor, no? From the soil, escaping, no? From the, kasi may soil yan, of course, no? Soil or rock na mayroong fracture, mapipick up nun while you are walking there, kasi you do not know where this is. If you plot the mercury vapor, no, that was read by the instrument, you will see ang pattern niya ay magkakaroon ng spike itong portion na yan ng mercury vapor reading. So that means when you go back to your camp and you look at your data, merong spike, then you know there was something you passed by, no? Na possible source of mineralization. Ganun sinosolve. Not by sampling the rock anymore, but using a mercury analyzer to walk across. Yan yung modern technique today. So yung chance of missing it is lessened. But the problem there is you cannot always use the mercury analyzer when it is raining. Kasi hindi mag-escape yung vapor kasi yung rainwater will seep down into the fracture. Hindi maka-escape yung mercury vapor. So it's only used for summertime and not during the rainy season, yung mercury analyzer. Okay? Now it becomes, of course, here is another example of using structural geology and stratigraphy. So the same, no? You can only do this if you know you do a lot of geological work, field mapping, and structural studies. Not to be able to come up with the model, because here at the surface, you have a value, whatever that value is. Let's say heavy metal is your lead. No? So merong pattern, may increase here, no? And it is interpreted that there is a particular fracture where there was mineralizing solutions coming from your original ore body. It's the same as the previous one. No? And it is important that there is an interpretation that is the basis. No? When you tell your boss there is a chance, it is by presenting him this type of interpretation. And before you can actually present that, you do geophysics also. No? You test if there is an anomalous body and if there is a actual fracture, no, below this your pattern, no, that have spikes or that indicates presence of high value of a particular element or metal. Okay, becomes more complex when you add other aspects of geology, no? Structural geology, stratigraphy. Okay, now let's go to a porphyry copper. Ito na yung last part of our lecture. Yung porphyry copper is an important deposit, no, in island arcs or even in continental arcs. So this has been well studied. And in fact, it is even also applicable to the Philippines. So let's look at it. This is the Lowell and Gilbert, typical, no? Alteration, zoning. Yan. So, where is your ore body here? It is usually found here on the phyllic and potassic zone. Yung mga tenga na yan, nandiyan yung mga porphyry copper systems. It's the boundary of the phyllic and the potassic zone. Ayan. Then outward is the argillic zone, and then the propylitic zone is the outermost. Okay. And then in the deep-seated part of your potassic zone, it is more of the richer in calcium naman. Nagiging calcic rich instead of potash rich. So that's the way to see, no? If you are in the bottom or at the top of your porphyry system. Okay, but now let's look at the geochemistry. So let's say now at your left is your profile. This is a profile. Do you see this, class? Hello, nandiyan pa ba kayo, class?
Yes,
Sir.
Paliitin ko muna kasi ito pala yun. Yung equivalent ng ore zone, no, ito sa bottom. Do you see that? The ore zone? Ayan. Ayan, ore zone. Yan yung ito yung section, of the ore body. We are now looking at a vertical profile. So ore zone, no? Ayan. And then may argillic ka sa side. And the ore zone is in the phyllic. Yung upper part lang yan. But actually, phyllic and potassic zone yan. Nasa boundary yan. And then argillic again to the right side. Ito ay sa isang porphyry copper deposit in the United States. Okay, let's say that. it's a deposit in, let's say that, US. Okay, so they first plotted so they did the sample across this argillic, phyllic, and again back to argillic. So it's around, if this is 200 meters, this is around 1 kilometer, no? Or more, no? 200, 400, 600, 800, 1,000, 1,200, 1.6, no? This whole section is 1.6 kilometers across. No? So very wide kasi porphyry copper. So when they plotted the copper values in the rock and across the ore zone, of course you will expect yung copper will be increasing towards the contact ito, and then you will get the ore values. Actually, the values of the ore, no? It becomes the highest. And then as you go away further, no, to the other side, you will expect, no, from the contact it will start decrease also, no, yung copper. But you will see yung mga anomalous values of copper are exceeding, no, even up to 500 meters away from the contact. 500 meters ang lawak niya ng dispersion ng copper. If this is the level of your normal or background, ito na yung start niya, it's around 500 meters, and maybe the same, no, for the other side, or maybe much more copper. For the sulfur, of course, yung sulfur naman is found in, even in the argillic and phyllic zone, you find, pyrite kasi doon, may mga pyrite. Kaya yung sulfur is always present, ubiquitous nga ang tawag. Maraming accessory minerals na even the pyrite, kaya you cannot get a perfect separation of the sulfur. Diba? It just appears as a flat value there, but it also extends farther away, no? Maybe also around 500 meters because of the pyrite halo. Ayan, nakapaligid din. Not much, no, to say about the sulfur, but it is not a very distinct to say, no? It actually shows you the main ore zone. Okay. Now for moly, wag na muna yung moly. Now for rubidium, yung rubidium and strontium are found in the potassic alteration also, in the potassic rocks. So yung rubidium also increases here, no? Why is it increasing there? As I said, no, sa potassic rocks, meron ka daw potassic alteration that is overlapping with your phyllic. Yan. So rubidium appears to be a good indicator of the ore zone as well kasi nandun siya. However, on this side, it is increasing, but on the other side, does not show the actual boundary anymore. It is diffuse yung kanyang envelope. Yung pattern niya is diffused on the other side. Okay? Diba? It's not as distinctive as the copper. Okay, next is zinc. Yung zinc, look at zinc. Yung zinc biglang nag-i-increase near the boundary. It is increasing near the boundary, but when he hits the boundary, instead of increasing, it becomes less and less. And then when it reaches the other boundary, it increases and then goes back to the normal average value. So yung zinc appears to be opposite, no, of what copper is doing in its horizontal profile. It has a negative anomaly. When I say negative, instead of positive increasing, it is decreasing compared to the value in the surrounding rocks. This is for the horizontal class. Meron siyang relative decrease. But it also indicates you are approaching the contact. Kasi ito, nag-i-increase siya towards the contact. And in this other side, it is also near the contact. No? Pinaka-highest value niya there. It is good for indicating closeness to the contact, approaching the contact. Okay, yung strontium has the same. No, look at it. Strontium has the same pattern as zinc. There. So yung strontium is also found where? In the potassic zone. Also, no, yung strontium follows the behavior of the zinc, no, in the horizontal profile. Kasi cross-section niya, no, pero yan yung sampling niya, itong along that line, no, across horizontally. Okay, so zinc and strontium partly, no, yung strontium very, very small lang naman yung indication niya, no, that it is approaching kasi mababa. Still very low yung kanyang pattern, yung contrast niya from the background, which is the one on the line, background yan, and then very, very low. And then on the other side, in fact, it is not showing any increase. But it is the zinc that has a better pattern. It indicates you are closing or approaching the ozone. Okay? So, last I will show you is this one, molybdenum, which is a striking pattern. What is it? The molybdenum becomes high only at the contact, along the contact with the ozone. So, you will see, ayan yung ozone mo, ayan yung moly mo, they are at the contact. They become high at the contact. So, para siyang tenga, no? Yung pattern niya, they are only high along the contact. If you use these elements for exploring in that area, so it's applicable, no, for porphyry copper of similar nature, no, in continental, no, sa continental US. This is a model that can be used for exploring for other porphyry systems by using what? At least you can use 4 elements here. No, of course, yung copper, given na yan. Anyway, that's the indicator element. Yung sulfur is not much, but the moly is the best in terms of showing you the boundary. Kasi itong copper, no, hindi naman clear yun ng boundary mo, basta gradually increasing to the ozone. But the moly is one of the best. You are at the contact, no, boundary. And also you can use zinc because while exploring, kasi you do not know where the ozone is, but when you are able to get increasing value, that means you are approaching a possible ozone or mineralization based on your samples in the rock. Yan. Also in the other side, there you're approaching the contact. Di ba, class? So, these are pathfinder elements, your zinc and your moly, but your indicator is your copper. If you combine these 3, maybe partly you can also use maybe this strontium, no? Maybe combine these 4, you will get a better picture, no, of what you are going to do further target, no? You define a further target, no? To do additional sampling. Okay, so because of that, these are what we call your priority metals that you will use, no, for your exploration work, because they can help you define the possible ozone. And also what? They become vectors. Ano yung vectors? Direction. May directional meaning. Diba? Yung zinc gives you a direction saan yung you are approaching, no? It increases. And then the molybdenum is a better one. It already indicates directly the contact. So yung zinc and moly, pag pinag-combine mo, sure ka, you can hit the, most probably, you know the direction where the ozone is. Okay, so that is how it is used, no? The studies of previous exploration work, they can be the model for exploring of other deposits in the same area, no? Hindi ko sinabi you apply this in the Philippines, China, no? There should be a separate model for also in those areas, no? Kasi they have different rock types, tectonics, structural geology, stratigraphy. Those are factors, no, also. Okay? Any questions, Preston? So now let's go to the, ito naman ay, let's go to the, ito vertical, kanina horizontal. So ito vertical. So let's look at the right. Alright, ito yung ozone mo. Yan, no? Ito, yung ozone is here. No? That's the ozone. Okay, it was cut by a fault. So walang mineralization below this, but there is the ozone here. So let's look at, they use several other metals and elements. So ito yung merong mga parang bulge. Yan yung corresponding sa ozone, no? Yung nagbabulge siya. No? But this is a vertical profile. Nasa potassic and feeling siya. Yung sericitic ay sa potassic din. Sericite, clay. Sericite yan, no? Is philic. Ceresite pyrite actually yan. Okay, and then potassic is sure. We have potash feldspar. So again, copper, there, no, it is a gradual increase vertically until the peak reaches the ore zone. So okay, anyway, we will mine that higher values. Of course, that is already our best, no? Is the indicator. But again, if we use yung ating other metals and elements, look at the molybdenum in the vertical profile. It also, it is similar to the zinc. No? Yung kanina, yung sa zinc, di ba nag-i-increase siya towards, and then along the contact here, no? There's the contact of the ore. Nag-increase siya, pero even inside the deposit, may portion na, it also increased. So yung moly looks like a good indicator also of the or deposit, no? Because aside from showing the contact and it is approaching the ore zone, it is also indicating the ore body itself, like the copper. Kasi yung copper diffused, eh. But here, very specific, nandun yung bulge niya. Diba? And then maybe this is a deposit that contains also a lot of molybdenum as accessory. Kaya ganun. And then here is the gold. So ang gold, merong portion na increase, but the bulge there of the higher values are also found within the ore zone. So maybe you can say, meron di siyang gold content. Maybe possibly it can become potential income if you are able to recover the gold. Very good. Silver, the same, no? It's also inside the ore zone. Yung cobalt, ito naman, instead of the moly showing where is the contact, it is the cobalt there. Look. Yung cobalt, biglang dun sa contact naman siya nag-increase. Parang nag-exchange sila ng role ng molybdenum, mas definite na nandun siya sa contact, no? Yung bulge, yung spike or increase in value. Now for zinc and manganese, di ba yung zinc negative? Ganun din, look at the zinc here, no? Even the zinc, nasa negative. But anomaly, instead of increasing, it is decreasing towards the ore zone and inside the ore zone. Manganese, follows the same pattern of the zinc. It is outside, it is high, but it becomes low or decreases towards the ore body. Okay, yung thallium, partly, similar to manganese zinc. High siya sa outside the ore body and then decreases towards the ore body. Rubidium, the same, they are decreasing. Kaya lang yung potassium, you cannot avoid, no? Kasi may potash feldspar ka rin dito, potassic alteration. So, it is increasing because of the potassic alteration. But it is not definite, no? Because there are other sites, mataas din yung alteration doon, no? Pero there is no mineralization in those zones of potassic alteration. So, yun lang ang difference. Mas hindi siya specific to define the actual ore zone. Because other portions of the rock are, meron ding portions that are altered by potassic alteration. Sulfur, as the same, no? It's with the pyrite content, it is ubiquitous, scattered. Kaya not definite, no, where the ore zone is, kasi even in the surrounding rocks, you have accessory pyrite. Then the selenium can also indicate, no, it is increasing towards the ore zone, para siya ring zinc sa horizontal profile. It helps, no? It is increasing towards the contact and also inside. Okay, so yun ang mga pathfinder elements that when you plot them together or you overlay them, they will help each other, not to define what is the actual ore zone. Okay, so I've shown you the vertical and the difference in the horizontal. Okay, so but since we are doing more work on the surface, di ba, pag nag-drilling ka na lang to, dun sa mga exploration geologists, we are more concerned what we find in the surface. And ito yung summary, class. This is the summary of what we will do, what we follow, no, for exploration purposes. for porphyry copper. So ito, generalization na to. If you're sampling on the surface, yan, you will expect these things. Number one, ito muna, yung pinaka-widespread. Yan yung gray-colored pattern. So you see, it's not equidistant. It is not a predictive pattern. No? It is tawag doon? Non-uniform. No? Ayan. So, it does not follow any pattern actually. No? It depends on the condition. So, you will see the one with the gray color pattern, envelope, oriole, in a porphyry. So, the porphyry copper system is the one here in black. No? Yan yung porphyry or body mo. So, surrounding it, merong malapit, merong mas wider space. Anong elements ngayon na kailangan natin i-analyze sa samples natin on the surface, no? Rock, if we are analyzing rock. So here, the anomalously high copper, zinc, lead, manganese, sulfur, and selenium are found with the wider dispersion on the surface. No? Horizontal yan, dispersion. Yan. Anong elements yan? If they are more widely spread or dispersed, these elements are what we have to analyze in our samples when we are still doing what? Semi-detailed. No? When we are analyzing every 100 meters distance or more. Diba? Kasi we have a better chance even at 100 or more distance, we are able to get samples inside this envelope kasi we do not actually know where this is. No? We can only plot this when we have the value. So, that's the example. I'm just showing you. But the pattern it made is wide. So even you sample wider distances or intervals, may chance ka to hit some portions of this wide envelope. And ano elements can help you get this wide pattern? They are your anomalously high copper, zinc, lead, manganese, sulfur, and selenium. Yun yung summary of this study na pinipresent. Okay? And then, if you are now doing follow-up, more detailed, you're doing more, you mas malapit ka na sa ore after going back, you are now sampling every, let's say, 20 meters, 40, 60, less than 100 meters. What elements can you use? Kasi that means you are able to sample this envelope, itong smaller envelope that is nearer the ore body. Ito yung gusto nating hanapin, the ore body. Pero we have now to sample more closely spaced intervals. So within this original widespread, we will add samples that are closely spaced, maybe 20 meters, 25 meters distance. You have a chance to also hit this smaller envelope or dispersion pattern. Ano yung laman nun? If you're able to get these samples and you plot the values, you will find this one. The anomalously high, it will increase in copper, moly, gold, silver, sulfur, and selenium within this envelope, nearer or adjacent to the ore body. But they will also get negative anomaly. Ano yun? Yung becomes less. Ito yung nakita natin. Zinc, manganese, even lead and thallium become lower, as you approach or you are within the core zone. Okay? So yan, ang combination of positive and negative anomalous values that can be expected. Okay? So in a way, you are now have a model in a particular area if you are able to get the data of the previous workers in their own exploration work, and then you can come up with a model what elements that you can use for a semi-detailed or maybe even regional, semi-detailed and detailed analysis of your rock samples. But it depends also on the interval, as I said. If you want widely spaced intervals, you analyze for those elements that have a wider dispersion. if you want a closely spaced sampling to be used, you have to analyze elements that are expected to be found adjacent to the ore body, just surrounding it. Okay, and finally, if you're in the ore zone, of course, you just analyze mainly the indicator elements, no? Of course, nasa ore zone na. But you also try to see if there are other elements that, like the gold, na in Felix, the gold becomes a indicator element. Dati porphyry copper lang yan, but when the value of gold, the price of gold became very high, gold became an indicator element na siya pa yung nag-earn for Felix rather than the copper, kasi yung copper bumaba. Yung gold that earned for Felix, no, in the 1990s, no, up to early 2000. Up to today, no, may gold pa rin na nag-earn for the Felix deposit. That's in Baguio, no, yung Padcal. Okay, so that's the summary for a porphyry system. And now you can have a better understanding of the use of envelopes and their patterns and the elements, no, that have different also profiles or patterns, no, around deposits. Okay, and finally, how do you now correlate? Now, there is a more, you can actually do statistics to correlate, no? Para hindi ka na mag-overlap ng maraming colors, kasi if you have 10 elements, ang hirap, di ba? You will overlay different colored patterns, no? It is difficult. So what is done now? They use statistics. Ayan. So in this case, ayan, no? They use statistics. Dati, so let's say this is a vertical, ano? Okay, ano? Vertical ore bodies, mga veins din, ano? And then bismuth, copper, cobalt, tungsten, and yan, yung apat na elements. So, because the patterns is a bit erratic, no? Ang hirap to be able to make a definite, no, correlation. What the others, this was done by the scientists. They did the addition, they added the values of your bismuth, copper, cobalt, and tungsten, and when they added it, ito na yung naging pattern ng anomaly. So, they have a better, indication. No? Most of these areas are anomalous, and then these are the higher values there. May mga higher values ka dyan, yan. Where the ore zone, no, can be expected in this type of deposit. Ito naman, another approach is they multiply the values. Ayan. So, almost the same, no? But by multiplying it, they even found, other high values of the ore zones. So, but that is difficult, no? Kasi yung addition and arithmetic approaches. So, if your value is 0.1 and then the other is 100, when you multiply it, bababa pa nga yung 0.1 ppm times 100 ppm. Di ba? Bumaba pa. So, it's difficult not to just multiply or even add. Kasi you add 100 and 0.1, halos walang difference, no? 100.1 is the value you get. So now we use, finally, no? We use these different statistical methods. But I will not explain this anymore. But you can, when you do actual correlation of different elements, no? They call it multi-element statistical methods, no? So that you can come up with a pattern, no? Ang kinukuha mo nila yung values ng combination of these elements, no? To see a pattern. These are called discriminant analysis, factor analysis, and the cluster analysis. So basically, these are statistical methods that see combinations of elements and their meaning to geology and mineralization. Yun na lang muna sabi ko. No? Because, of course, it is a manipulation of the data using statistics naman. And then, it gives a better result that can be interpreted in terms of geology. Okay? Yun lang muna. But the end point is coming up with a pattern like this that gives you more confidence, no, to decide, no? So let's do geophysics here. May target tayo. Ito yung it's expected from GEOCHEM, no? Meron parang nag-i-indicate may mga highly anomalous sites by GEOCHEM. Baka nasa malapit na dyan yung actual ore zone. So something like that, it is a way of adding to the target, no, or the development of the possibility of mineralization being present in an area. And these are the modern methods. So in this course, you will learn at least the basic. It is correlation coefficient. We will learn that. It's just among two elements, and then you will understand how it is interpreted. Okay. So that ends the lecture here. Unless you have any other questions, class. May questions pa ba?
None po, sir.
Okay, so next week, I will send you an email, no? And the coverage of your short quiz. So essentially, I told you it's lecture 1 and this one, this is lecture 2. Hindi na tayo umabot sa isang no? Lecture, no? But anyway, next week, na yun naman yung other lectures will just go on next week. Okay, class? Yun lang ang coverage ng ating short quiz. So I'll give you instructions, no? As long as ang output natin, you will convert your Word file answer sheet to PDF when you submit it to me. So yun lang, you can actually convert it, no? Meron naman yan sa email, no? Sa internet, no? Meron free conversion. After you have answered your Word file questionnaire, you convert it and then you send it back to me. So may instructions that I will give. Okay, so okay, class. That is the end of our lecture today. So keep safe.
Thank you po, sir.
Sir, thank you po.
Thank you, sir.
Thank you, Ren. Thank you.
Salamat po.
Thank you, sir.
Okay.
Keep safe po.
Keep safe. Nawala yung aking screen. Okay.